Hi guys, a very good morning everyone. Welcome to all the GATE 2024 aspirants, and yes, today 11th of February, finally the GATE examination, conducted by Indian Institute of Science Bangalore, has also been conducted for electronics and communication engineering, and there is going to be electrical examination in the afternoon slot, that is from 2:30 p.m. Okay, so the time is 12:32, and students might have just started coming out of the exam hall. Okay, so we'll be very soon getting all the updates about the examination, how many MSQs were there, what was the difficulty level. Okay, so that you can guess, as per your marks, what rank you can be expecting. Okay, as per all the memory based questions we get, what are the answer key, because out of just after coming out of the exam hall, you are very curious whether your answer key is right or wrong. So whatever memory based question we'll have, we will discuss all the question answer with you. So over to you, Aman sir.
Welcome guys, welcome to BYJU'S. Not only just curious, students may be curious about knowing the answers, but it is also useful for the second session students to understand how many MSQs, how is the pattern, difficulty level. Generally, students will expect ISC Bangalore is tougher paper.
Correct.
Let's see. Within few minutes, we will be getting the questions. Whether the questions are really difficult or how many questions from each subject, all that detailed analysis we are going to give you. And like every year, we are also here for your big day, because all one year or more than 1 year also students preparing for this exam to perform well in this, to get settled in your career. Here, this is a big day and the special day for you to know your performance also in the examination. We are here. So, Sanjay sir.
गुड मॉर्निंग स्टूडेंट्स. नाउ गेट एग्जाम इज ओवर. अब हम लोगों का काम स्टार्ट हो रहा है. हम करेंगे एनालिसिस और बहुत सारे क्वेश्चंस आप सॉल्व करेंगे. अब देखिए, जो पेपर हो गया वहां कितने मार्क्स आ रहे हैं, और जिनका इलेक्ट्रिकल का पेपर जो बचा हुआ है उनको एक आइडिया लगेगा कि कैसा पेपर आने वाला है. हाउ मेनी नंबर ऑफ एमएसक्यू, हाउ मेनी नंबर ऑफ एमसीक्यू, हाउ मेनी नंबर ऑफ एनएटी. और साथ में आप एक एनालिसिस करके तुरंत जज कर सकते हैं कि आपका पेपर कैसा बना है और कितने मार्क्स आपके आ रहे हैं. तो स्टे ट्यून विद अस, राइट गाइस. और साथ में क्वेश्चंस बनाते हैं. चलिए आइए साकेत सर.
Guys, before that,
प्लीज सर.
Yeah. So we are getting some update from Sujit that the paper is tough and lengthy. All right. Okay. Let's see. Hi, Sai Krishna. Yes, I remember you. You're the old student of BYJU'S. Did you appear for GATE 24? How was your exam if you appeared? And guys, quickly share the session to all.
Please share it to everyone, because some students may be still not aware that we are live and we are getting the response already. Some students already sharing the paper level, difficulty and all. Soon we may be getting the questions also. Let's see and solve the questions.
Yes, definitely. Okay, you are in GALE PSU. Okay,
yeah, Sai Krishna already working in GALE.
Yes.
Nice, Sai Krishna, to see you back on our platform again.
Yeah.
Hope if you also have any questions, please share us. We'll also provide and help the students who wrote the exam today and are going to write the exam in the afternoon for electrical students.
Correct. So come on, guys.
So by the time, I think we will see the last year analysis, how was the pattern and all. Let's compare this with 24 exam pattern. I mean, pattern means difficulty level, weightage, all those details. Let us compare so that we can understand the trends, how these trends are. But by the time, guys, please share it to everyone so that maximum students can understand how the paper level is useful for the next session as well. Saket sir, you want to say something?
Yeah, so good afternoon, everyone. So as some students are saying that the paper are difficult or easy, it is asking. So Bablu, the paper, as we have got up till now, that the paper was a little bit tough and lengthy. So, but in the student point of view, it may be difficult overall scenario when we will take the feedback from all the other students as well. We will analyze it and we will tell you the expected cutoff and how was the paper and what could be your score, the safe score, and this last year in compare with the last year, what is the cutoff in this year? So that we will discuss. So till we get the questions, let's analyze the previous year. How was the previous year trend, and accordingly you will understand that what was the means what is going to be for GATE 2024. Sir.
Actually, generally different students will say different response, that some students say that it is difficult, some students say that it is easy, lengthy, etc. That is why we are all here, guys. We will take the inputs from various students, not only from the students, because it also depends on their preparation level. If students are preparing and everything is See, for us, the way of looking at the difficulty level is different. For students, it is different. So
Yes.
that's why we'll take the input from different students and also from the previous exams and consolidate all these things, and we'll give you the correct picture by another 15-20 minutes, so that you'll also have an idea how the trend is going on.
Yes, definitely. So, sir, by the time, let's get started and let's talk about, some data that we have from the last year.
Yeah.
Okay, because, students might have already an estimate in the mind ki how much they may be scoring.
Correct,
Okay, so
correct.
based on their score, how much they'll be expecting, sir?
Yeah, this is about the this is the information about the students, how many students registered, how many students appeared. With this, you guys can get an understanding of how many students are there in competition with you. Right? Last year, if you see, this is for 2023 GATE examination. The total number of students registered were 70,361. So, okay, it's not a big number, in fact. So, out of the 70,361 students, not all students are appeared the exam. So, you can see generally whenever we talk to the students, everyone will say that it is so difficult, and second is it is so competitive. So many students are writing. How can we compete with them? Here you can understand, guys, from the last year analysis that competition is not in lakhs, not even in thousands. You can see here 70,000 students appeared. Out of that, 70,000 students registered. Out of that appeared are only 45,000. So that means you are competing with 45,000 students only. Out of that, the students qualified are only 8,000, 8,800, close to 9,000. So that you can understand. The students who qualify the exam are only the competitors for you. So that means actual competition, if you can qualify, how many marks you need just to qualify? Close to 30 marks, isn't it? 25 to 30 marks is sufficient. So if you can score minimum 25 to 30 marks, then you will be in the race, and then the actual race begins where you are. So that means you are competing with only 8,000 students, or 8,000 to 9,000 students, maximum 10,000. Let's take. So this gives us a lot of confidence. Actually, this analysis we every time give you. Even this time also, the numbers I don't think will be different from this. The numbers will be close to these numbers also for 24. I guess the numbers will be similar to this. Average marks of top 0.1 students will be 74 out of 100. That is for 2023. And the toppers mark, that is AR1 marks, are 90 out of 100 in 2023. But don't look at this number and get worried about this. This is not a serious number to look at, because this number is nowadays the trend has become like faculty are writing and getting these marks. Of course, faculty will get it because they are familiar and they are teaching subjects years together. They'll get the score like this. That's okay. But for students also, the numbers we can share you. You can see the numbers. Students wise, if you see the marks wise analysis, if you see, by the time, guys, please share the questions if you have anything. A question from GA, prime number factor of some data is given. Rakesh. Yeah. Rakesh is here already. Rakesh sir is checking the solution. Guys, we start the questions as soon as we get this. By the time, let us understand how the previous trends are. Okay. We will be in touch with the students to get the questions. Whatever they remember, immediately they are going to share with us, so that rest of the students will understand whether the answer is correct or not. And the next session students will come to know what type of questions are coming and how the weightage is. This happened even last year also. The trend of MSQs is different from EC electrical, and it is different for civil and mechanical. Whether the same thing is going to happen in this year also or not, let us wait and see that. So if you see the students versus marks, this is very, very useful and important data, especially for those students who are going to write the exam next year also. Not only for the students who are writing the exam this year, also for next year students or your juniors also. Reason is, you will understand where you are and where you have to be and how difficult it is. If you see this, the students who are getting less than 0 marks, so the students who are getting less than 0 marks are 1360 students. That means they are getting negative marks. Since negative marking is there, some students may get negative marking also. But if you see 0 to 10 and 10 to 20 are around 28,000 students. 28,000 students out of 48,000 students are less than 20 marks. That means these are not even qualifying. Not even qualifying. So 20 to 30 students are 8,000 students. That means these are in the qualifying range or above our qualifying range. So these are all not in competition for you. I don't want you guys to be here in this range. You should not be in this range. 0 to 20 marks कुछ नहीं मिलने वाला है. And trust me guys, I always say getting 30 marks is not that difficult in GATE examination. Just 3 subjects can bring you 30 marks. Maths, aptitude and any one technical subject can easily give you 30 marks. So only thing is your dedication and planning should be proper so that easily you can be in the qualifying range. That means you can eliminate these 30,000 students easily by just having 3 subjects seriously prepared. Isn't it? Guys, correct or not? Then comes to the next part. The students who are scoring 30 to 40 marks range are only 3,000 students. That means qualifying and above are only just 3,000 to 4,000 students. And above that, 40 to 50, only 2,000 students, 1,905. And 50 to 60, this is the sweet spot. 50 to 60 is 833 students. See how the number is. So the number of students appearing the GATE exam and the number of students scoring above 50 is just 833. This gives a lot of confidence actually and a lot of clarity what to do. Especially as I just told you, this is useful for the next year appearing students for 24, 25 and 26. And if you see 60 to 70, only 200 students are there, 204 students. 60 to 70 marks in the range. These are the toppers. And if you see 70 to 80 marks, just 37 students are there. That means to get below 50 rank, you just need above 70 marks. Isn't it? 80 to 90, there are only 2 students in 2023 GATE exam. Out of these 2 students, one is faculty, you all know. So they are not competitors for you because they are not going to take any admission in anywhere or PSU job in anywhere. So they are not competitors for you. So only one student is there in 80 to 90. And that student also, I remember, close to 80 was the marks. So if you see 60 to 90, there are only 250 close to students, 250 students close to. So that is where you have to be. So if you want to be in the race and if you want to get settled well, or if you want to get MTech admission in IITs, or if you want to get a PSU, better IITs, you have to be in this range from 60 to 80 range where the competition is very, very less. So that is where your target should be, guys. Yeah, some questions students are sharing, but they're not exactly clear for us to go for the solution. Yes, we got already a few questions received from the students. So Rakesh sir and Sanjay sir are already working on it. So by the time I'll give you this analysis of the previous exam and the trends to understand, we'll get the questions as soon as possible and we'll share the solutions. Please stay with us and share with other students also so that everyone will understand how the difficulty level of the paper is. Okay. Next is subject wise. If you see the weightage and analysis, how important each subject is. More or less, the weightage is similar in technical subjects, but year by year, there will be slightly different. And in 2023, especially if you see how many 1-mark questions are there, how many 2-mark questions are there, is the table summary here. You can understand. Let me start with this side, control systems. We have 1-mark questions, 1 question, and 2-mark questions, 3. Total 7 marks appeared. So total 7 marks from control system. This is for 2023, guys, not 24. Remember, 24, our team is working on. Just now we started receiving the questions. For 2024, we are working on it. Our team, backend team is working on this type of data and details also. They will provide you soon in a couple of minutes. Digital circuits in 2023 asked for 4 1-mark questions and 2 2-mark questions. So total is 8 marks. Electronic devices, 3 1-mark questions and 2 2-mark questions. Total marks are 7 marks. Similarly, signals 3 plus 4, total 11 marks. So this is dominating in technical subjects in 2023. Communication also higher weightage, 2 1-mark and 4 2 marks. Total is 10 marks. That's what I told. Maths, aptitude, and any one technical subject, if you say, for example, if you are good at signals and maths and aptitude, easily you can get 30 marks, isn't it? Exam is bit tough. Ritik is saying exam is bit tough. Let us see, Ritik, because this is the feedback we wanted. We will consolidate all the data from all the students, and also we see the question level. We will also know whether the question is really difficult or not. Once we get the question, we'll consolidate and update you how difficult the paper was. You know, there are different things. Yeah, we got a question. We continue this discussion a bit later. By the time we got a question, guys, let Rakesh is discussing. Over to you, Rakesh.
Yes, sir. So guys, I have started getting the question. I have 3-4 questions right now with me. Okay, let's start with the technical part first. Okay. Question तो बहुत सारे आ गए, but okay, let's keep discussing, and parallelly, Sanjay Rathi sir and Saket sir will also be ready. Okay, ji.
Ask to share.
Yes. So guys, now the questions are starting. The real game is starting. And do not forget to share the session, guys. Everybody to share the sessions. Okay. We're live with the questions now. Okay. So MSQ question. I'm starting with a MSQ question. As expected, MSQ aega. Okay. So a causal discrete time LTI system. There is a causal LTI system with the transfer function. Okay, मैं brief में लिखते चलता हूँ. The transfer function hz is given to you. That is 2z square plus 3. That is the 2z square plus 3 upon z plus 1 by 3. Z minus 1 by 3. Sir, by the time Saket sir or Sanjay sir, if anybody ready, I have 3-4 with me.
Right. I'll check.
Okay. All right, some question is shared by Akshay also in the comment box. Okay, let's see that. Okay, so 2z square plus 3 upon z plus 1 by 3, z minus 1 by 3. Okay, which of the options is or are true? MSQ question है, पहले ही लिख दिया है. Okay, the system is minimum phase. Come on, everybody can tell me. System is minimum phase, yes or no? Okay, already if you have noted, we have solved these questions, MSQ questions from Z transform also. Okay, the final value of the impulse response, okay, is 0. Okay, option number C. Initial final दोनों यहाँ पे बोल दिया है. Initial value of the impulse response is how much? Is given to you as 2. Option number D. Okay, system is stable. Come on, everybody. Did you see this question? Verify, because all this is memory based. All this is memory based. Did you get this data? Come on, everybody, rectify with me. Come on, everybody, quickly rectify with me. Okay. Chalo. Okay. So we have a causal LTI system, 2z square plus 3 upon z plus 1 by 3, z minus 1 by 3. Now look into it. What are the poles there? Okay, what are the poles? The poles will be minus 1 by 3 as well as plus 1 by 3, and both are inside unit circle, and the system is already mentioned to be causal. Okay, there is already a causal system. So what is the combined condition for the system to be causal and stable? The combined condition for the system to be causal and stable is that all poles inside unit circle. Okay, both of them, okay, they are inside unit circle. Okay. They are inside unit circle. So hence the system is causal as well as stable. Okay, so stable hoga, dear. D is the correct answer because it is already causal. Otherwise, if they only have stability condition, then we need to check ROC. ROC including the unit circle. Okay. Now, dear, is the system minimum phase? Is the system minimum phase? Okay, so have a look into the zeros. Definitely when you solve for the zeros, you are going to get z square is equal to minus of 3 by 2 and z is equal to, there are complex conjugate zeros, plus minus j root over 3 by 2. Okay, plus minus j root over 3 by 2. Okay, the definitely it's greater than 1. Okay, plus minus j 1.22 around. Plus minus j 1.22. Now, dear, they are outside unit circle. Okay. Okay, mod z greater than 1, outside unit circle. Okay, so now for a system to be minimum phase, all poles and zeros are inside the unit circle. So is it minimum phase? No, it is not minimum phase. Come on. Yeah, guys, by the chance. Okay, by the time you can also rectify whether this question was there or not, because everything is memory based. Okay, so we need your confirmation as well, although we have got it from authentic sources. But now, next one, final value and initial value. Now look into it. Okay, is the initial value theorem or final value theorem applicable? Yes, both the poles are inside unit circle. I can apply the final value. And whenever all the poles inside unit circle, dear, I have taught you this condition. Okay, both inside unit circle. Okay, no need to check. X infinity will be 0, 110%. 100%. When all the poles are inside unit circle, strictly inside unit circle, final value will be 110% 0. Okay, or you can apply by, okay, or you can check by, okay, you can check by x nahi yahan pe h bolenge, whatever it is. We have the impulse response h infinity. Okay, or you can find, how you can find h infinity? Okay, you can find limit z tending to 1, z minus 1 into hz. Okay, इसको लिख देता हूं मैं थोड़ा सा clearly यहाँ पे. You can find by this formula. Limit of z tending to 1, z minus 1, hz. Okay, but whenever all the poles are inside unit circle, it is always going to be 0. Okay, it is going to be 0. Okay, so B is also the correct answer. B is also the correct answer. Okay, what about C, initial value? Initial value theorem is applicable. Okay, if the degree of numerator less than equal to degree of denominator, it should be a proper transfer function, not necessarily strictly proper. Okay, so yahan pe yes, hz is a proper transfer function because degree of numerator equal to degree of denominator. Whenever less than or equal to degree of denominator, it is proper. And in that case, the initial value, as you know, is calculated, h0, impulse response ke liye, is calculated as limit z tending to infinity hz. Okay, now what is going to be limit z tending to infinity hz? देख लेंगे dear यहाँ पे. It's we can z tending to infinity direct mathematical rule we can apply ना. Coefficient of z square in numerator divided by coefficient of z square in the denominator. That is 2 by 2 and that is equal to 1. That is 2 by 2 and that is hence equal to 1. So that is what is h0. Correct? That is what is h0. Okay. 2 by 2 tha ya 2 by, sorry, 2 by 1 it is basically 2 by 1. Numerator में 2 है, denominator में 1 है, तो answer will be 2 and hence yes, this is also correct. So correct answer guys, B, C, D. Yes dear, correct answer here is the B, C, D. Let's move ahead to the next question then. Okay, let us move ahead to the next question and confirm me whether these questions were there or not. Okay. Next question dear. Okay. All right, a very simple question in the context of Bode magnitude plot. Okay, with respect to the Bode magnitude plot, okay, a slope of 40 dB per decade. A slope of 40 dB per decade is equivalent to how much? Is it equivalent to 10 dB per octave? Decibel to decade to octave conversion है dear ये. Okay, option number B, it is equal to 20 dB per octave. No, that is also wrong. Is it equivalent to 6 dB per octave? Okay, that is also wrong. Okay, is it equal to 12 dB per octave? Yes. Okay, this you should be knowing, guys. The answer is D. A slope of 20 decibel per decade corresponds to 6 decibel per octave, and that is why 40 decibel per decade corresponds to 12 decibel per octave. Simple one. Okay, simple है. ठीक है. Next question क्या है, dear? Next question is here in front of you. In the Boolean function, so there is a Boolean function of 4 variable given to you. Summation of the minterms 0 to summation of the minterms 0 to 57. 0 to 578, 10 and 12 and 13. Okay, 10 and 12 and 13 and 14 and 15 also, sorry. 14 and 15. Okay, what are the essential prime implicants? Okay, so as expected, I have put this topic also, you know, when I told you the 51 most important topics for electronics, सारे के सारे आ रहे हैं. Even there is a question of Z transform. Okay, ठीक है. Right. So, you know, even there is a Z transform, even there is an essential prime implicant, all the important things are turning up for you. Okay. What are the essential prime implicants? There are the 4 options. Okay. What are the essential prime implicants? And there are the 4 options given to you, and that is given by BD, B bar, D bar. Okay. Then you have the option AB, B bar, D bar. Then you have the option BD and AB. And then you have the option number D, BD, B bar, D bar, AB. Okay, guys, come on, just keep verifying whether the question you have seen this or not. Okay, so to calculate the EPI, I will just again follow the regular K-map method. That is the simplest shortcut to comment on this. Okay, and we have the function of 4 variables, respectively A, B, C, D. And now let me plot the minterms here. Okay, 0, 2, 4, 5, then 6, 7, then coming to 8, 9, this is 10, 11, 12, 13, 14, 15. 12, 13, 14, 15. ये सारा है 12, 13, 14 and 15, 8, 10. Come on, everybody. So first of all, let us form the possible groups here. Okay, the possible groups here. Now look into it. This is definitely a quad going to come up. Okay, all four corner ones also make the quad. All four corner ones also make the quad. Okay, now what about this? Okay, will you be taking as pair? No, na? Okay, what is a prime implicant? Prime implicant is that particular group which cannot be combined with anything else. That should be the largest possible group. Okay, so you can't take a pair here because it is combined with another pair. It should be a quad once again. It should be a quad once again. Okay, all possible groups, whether it is 2 or 4 or 8, you have to form, provided that if you are making a quad, don't take the pair in that particular case. Okay, so all PIs are done. Okay, anything else left? Can you say anything else left? Any other PI can you judge from here? Yes, definitely there is one more PI we can judge from here. Let me first write down the PIs also for you. Okay, there is one more PI that is going to come for you, and that is, look into this, dear. Look into it. 1, 2, 3, 4. Dear, 1, 2, 3, 4. This also makes a PI, na? Okay, 2 plus 2. Okay, that is making a quad. So hence that is also a PI. It has to be considered. It has to be considered. Okay, so now if I again put down the regions, this is A and B. Similarly, CD mein this is C, center mein D is high. So what are the PIs, dear? Number 1, center 1. Okay, that is BD. Okay, corner mein, that is outside B, outside D, B bar, D bar. Abhi I'm writing only PI. Okay, then this third row entirely, that is belonging to AB. Okay, and this quad that I have mentioned in front of you, okay, that is in A, but outside D. So that is AD bar. That is AD bar. Options are also made using this. Keval AD bar option mein nahi rakha hai. Now, what are the EPIs? The question is EPIs. Come on. Okay, EPIs. Now look into it. For EPIs, I will use that star method again. Okay, I'll highlight the minterm, I'll highlight that minterm which is included under a single prime implicant. Which is included under a single prime implicant. Which is included under a single prime implicant. Right? Okay. So that prime implicant, what is that? B bar, D bar. That becomes essential. Okay. Similarly, this is to be highlighted. Okay. Isko highlight bhi karoge, that is under the same group. Not a problem. This is also to be highlighted because this is the minterm belonging to a single group, belonging to only one group. And that group, that prime implicant becomes essential. And that is, yes, center wala tha, BD. BD is also essential. Okay, now this is under multiple, this is under multiple, this is under multiple groups, this is under multiple. So there are 4 PI, but on the EPI level, there are only 2, BD and B bar, D bar. Correct, everybody? How many of you agree with this? Okay, it's only 2, BD and B bar, D bar. It's only 2, BD and B bar, D bar. Correct answer is A. It is only and only 2, that is the BD and B bar, D bar. It is the BD and the B bar, D bar. Right, everybody? Chalo. Okay. Okay, only those minterms you have to highlight which are being covered under a single prime implicant, and that prime implicant hence becomes essential, because if you miss that prime implicant, okay, that particular minterm will be lost, and that is why it is necessary. Okay, the others are not necessary. Some of them will come, others will come under 2 category, maybe selective or maybe redundant. Okay, but utna nahi pucha hai, keval EPI pucha tha, so answer is A. Answer is A. Let's go to the next question now. Okay, what is the next question that I have is? Okay. Yeah, here it is. So suppose X and Y, okay, suppose X and Y are independent and identically distributed. IID bolte hain na isko. Let me write down IID. Independent and identically distributed random variables. IID random variables. Okay. Uniformly distributed. Both are uniformly distributed. Both are uniformly distributed. Okay. In the interval 0, 1. Okay. Question is, find the probability that X is greater than equal to Y. Find the probability that X is greater than equal to Y. It's a very simple question. It's ultimately a very simple question. If you solve it by a basic geometry, let's say this is X and this is Y. Both are identically distributed and independent of each other. Okay, they're independent of each other. So how you can take this then? Okay, how you can take this? Okay, X is also 0 to 1, Y is also 0 to 1. Okay, that makes the problem even more simple. Okay, X is also distributed in the range 0 to 1. Okay, so I can say that this is my sample space. This is my sample space. I mean, where you can find x and y, where you can find x and y, you can find x and y in any of this point at any of these point in the 2D plane that is mentioned from you. Okay, that is 0 to 1, 0 to 1. Okay. Now, when you want to talk about x equal to y, greater बाद में लेंगे. X equal to y is all you know is a straight line passing through origin. It is a straight line which is passing through origin. Okay, and that too with unit slope. And because it has unit slope, it is going to pass through 1, 1. It is going to pass through 1, 1. So this is what is the line. Okay, this is what is the line x equal to y. Okay, now dear, you want x greater than y. Okay, you want x greater than y, या vice versa बोल देंगे y less than x. Okay, y less than x means you want the below portion. Okay, y equal to x here, y equal to x, इसको इस तरीके से इंटरप्रेट कर लेते हैं. Y is equal to x. So what is the chance that y will be less than x? 50%. Yeah, many of you are coming up with the answer also. So it's definitely going to be this below portion, that is 50%. Okay. So what is this probability? Okay. So right now you are able to see because of equal division, it is 50%. In general, if it was not equal division, then आप क्या करेंगे? If it was not equal division, okay, then you do it by area. Okay, then you do it by area. You can find out this probability as favorable area, okay, divided by total area, because यहाँ पे uniform distribution है. Otherwise, if it was non-uniform distribution, we would go with the concept of joint PDFs and all. Okay, but that is not required here. That is not required here. Okay, so answer is going to be 1/2. Okay, 1/2, because favorable area is half of the total area. Answer is 1/2. Yes, correct. And Vikram and Surajit, correct answer 0.5. The very correct answer is 0.5. Simple सा question था random variable से ये. Okay, now what do I have next? Okay, yeah, I have another question here. Okay, in a number system of base R, okay, there is some base R given. Okay, number system से question कल computer science में ही पूछा था. In a number system with base R, okay, the equation x square minus 12x and just a second, x square minus 12x and plus 37 equal to 0 has x equal to 8 as one of its solution. Okay, what is the value of R equal to? Has x equal to 1 of the 8 as solution. X equal to 1 of the 8 as the solution. ठीक है. Chalo, tell me. So, definitely this is a number system in base R. If this is a number system in base R, dear, okay, 8 is one of the solutions. So 8 square. Now remember, 8 square means what? Okay, 8 square. 8 is in base R. X ko 8 rakha, but that is base R. What should be the value of base R? What should be the value of base R? Okay, so it's going to be 8 square minus 12 into 8 plus 37. Okay, everything is in base R. It should be 0. Okay, now let me start converting it to the regular base. Okay, let me start converting it to the base 10. So 8 remains to be 8. It's a single digit. Okay, so it's going to be 8 square. 12. How will I write 12? Okay, this is digit number 1. 1 into R. Okay, plus 2. Okay. Okay, 1 into R power 1 plus 2 into R power 0. Okay, multiplied by 8. 8 single digit, that remains to be same. And similarly, this is going to be 3R plus 7. My digit 0 and digit, position 0 and position 1. Na? Digit into base power position, base hai R. Okay, this should be equivalent to 0. So let me, complete the calculation here. That is 8 square, 64. Okay, minus 8R plus, nahi, wo minus hi jayega 16. Okay, plus 3R plus 7 equal to what? Equal to the 0. Okay, so solving everything, I should be having 5R equal to how much? ये हुआ 64 minus 16, that is 48. 48 plus 7, 55. Okay, okay, so R is equal to 11. Simple तो है. अभी तक का पेपर तो बहुत simple लग रहा है. Okay, maybe analog bit tough, Vikram is telling, so we'll come. Okay, digital was different than usual. Okay, let's see, Nitin, I've got 2 questions from digital. One is essential prime implicant, one is number system. Both are easy. Both are definitely easy. Okay, now next question again coming up from signal and system. Again coming up from the signal and system. Okay, question क्या है? A causal and stable LTI system. There is given to you causal and stable. There is given to you causal and stable LTI system. And क्या हो रहा है उसमें? Okay, with impulse response, causal and stable LTI system with the impulse response HT. Impulse response HT produces output YT. Okay. Produces what? Produces the output YT. Produces the output YT for input XT. For input XT. ठीक है. Now, property based question है, केवल question में कहानी लिख दी है. Okay, a signal 0.5t, a signal x 0.5t, okay, is applied. Just keep on confirming ये question आपने देखा था कि नहीं? Is applied to another causal and stable LTI system. Another causal and stable LTI system, okay, with the impulse response h 0.5t. Okay, what is the output equivalent to? 4 options hai, but I don't think we need to write down the options. Okay, we can solve it directly. Dekho, firstly, what is the output? An output for any LTI system is given by the convolution. So what is the output YT? Firstly, it is equal to x of t convolution with ht, because first you have the system with the impulse response ht and input is the xt. Okay, take it. Now, if xt convolution ht is equal to yt, okay, if that is equal to yt, then x of alpha t convolution h of alpha t, okay, scaling property, and the result is 1 upon mod a y of alpha t. Okay, this is what is the property to be used. Time scaling to be applied only when you have the equal scaling parameter in both, and that is given already. Okay, so x of alpha t, alpha 0.5 hai, x of 0.5t, convolution h of 0.5t, okay, is given by 1 upon 0.5 y of 0.5t, okay, and that's 2 y of 0.5t. 2y 0.5t. Come on, everybody. Yes, Vikram and Nitin, correct answer. Yes. Okay, so that is 2 y of 0.5t. Correct hai? Chalo. All right, dear. ठीक है. So now let me see if Sanjay sir, Saket sir, are you ready? By chance, are you able to listen to me? Are you ready with some set of questions? Yes, sir. Sanjay sir, Saket sir. Yeah. Sir, are you ready?
Yes, sir, ready. Next question.
Yeah. So, sir, just okay. So, Saket sir is here. Okay, guys. So, I'll be coming back live. I'll be coming back live right now. Saket sir is there, and Sanjay sir also there with some questions. Okay.
So hello everyone. So how was your paper? I hope that it was good. And I have one question from the communication. That is the topic from the random process. And we know that there is always one question from the random process and random variable. Already the random variable questions you can include in the mathematics also, that Rakesh sir has already been discussed. So the answer was 1/2. So that was also I have taken as a communication. But yes, it can be included in the mathematics also. So guys, this is the first question from my side in the communication, and a wide Gaussian noise WT with the zero mean and the power spectral density N0 by 2, right, is applied to a RC low pass filter, and an output is N of T, and we are actually sampling the output, and at T is equal to Tk, so we will get some random variable, and it is asking for the variance of the random variable. So let's start the discussion. We know that, guys, we know that if we want to calculate the variance, then we want two things, right? First is mean square value, and second is mean, that is mean whole square. So if it is given that the mean is 0 for the input, then automatically the mean for the output will also be 0, because this is expected value of yt, which is the output mean, is equal to h of 0 and multiplied with input mean. So the mean value of the input is given as 0. So irrespective of the which type of system you are passing through, the output is going to be 0. So this is h of 0. The input mean is 0. So the output mean is also 0. So if the output mean is 0, so the variance, this variance will become mean square value, correct? This is 0. So the variance will become mean square value. Mean square value means the total average power of the output. Okay, so total average power of output we will get. So now ultimately we want to calculate the output power, And to calculate the output power, if we have the output power spectral density, then we can calculate the output power. So we know that the area, right, the total area under the power spectral density. Okay, so total area under the power spectral density gives power of the process, right? Power of the process. So here we have to calculate the output power spectral density, and because this is passed through the low pass filter, right? We are passing it through the practical low pass filter, which is RC low pass filter in fact, and the white noise is given. So the white noise is having the power spectral density for all frequency n naught by 2, it is given. Then we are expecting the output. So what is the output power spectral density? The output power spectral density Sy of omega would be h of omega mod square multiplied with xx of omega. Okay, so that means we want to calculate this is RC low pass filter, so we want to calculate h of omega. So what is h of omega? The h of omega is nothing but 1 upon 1 plus j omega RC, right? This is for the RC low pass filter. Now, if I want to calculate h of omega magnitude square, then we are going to get 1 plus omega square r square c square. We are calculating the magnitude square. So if I convert it in the standard form, so we are getting 1 upon RC whole square, and this is 1 upon RC whole square plus omega square, right? So this is our h of omega mod square. Now we want this h of omega mod square. We have calculated Sx of omega is the input power spectral density, which is our n naught by 2. So we have to multiply these two and we have to calculate the area under this. So let's move into the next slide. Okay, just here. So we will be having Sy of omega, which is 1 upon Rc whole square, and we have got 1 plus omega square plus सर यही है ना इधर सर अच्छा इसमें ये okay, so this is omega square plus 1 upon RC whole square, okay, and multiplied with n naught by 2. So this is the output power spectral density that this we are getting, and now we want to calculate the area under this. Okay, so what will be the area under this? So the total area, the output power, okay, that is your mean square value, you can say. So let's write the total power or mean square value. Okay, that is nothing but 1 upon 2 pi integration from minus infinite to infinite Sy of omega d omega, right? So we will get 1 upon 2 pi, 1 upon A is here 1 upon Rc, okay, and tan inverse omega by A. So omega Rc, and we have 1 upon R square C square also. So we have 1 upon R square C square at the output, and the integration limit will be from minus infinite to infinite. So it is 1 upon 2 pi, and when you multiply this, it would be RC only, because this RC and this R and C will get cancelled. So we will left with 1 upon RC, and this is nothing but a tan inverse infinity minus of tan inverse of minus infinite. So we will get 1 upon 2 pi into 1 upon RC, and it is pi by 2. And yes, one more thing, that n naught by 2 is also there. So you can write n naught by 2. So n naught by 2, and here also we will have multiplied with n naught by 2. Okay, so what we will get, this pi and pi will get cancelled, and sorry, this pi by 2 and pi by 2. So there are actually pi only, na? Yes, so this pi by 2 and pi by 2 minus sign. Okay, so we will have 1 upon RC. So it is having the pi by 2 and minus of minus pi by 2. Okay. So it will be n naught, and here it will be pi. So this term and this pi will get cancelled. So we will get n naught by 4 RC. So n naught by 4 RC should come. Okay. So this should be your answer. N naught by 4 RC. Option C. Okay. Option C you should get. तो चैट नहीं दिख रहा है. Yes, n naught by 4 RC. Perfect. N naught by 4 RC. Okay, so n naught by 4 RC, that is your option number C will come. Option number C will come. Okay, Harshit, so what mistake you have done, you can check. Okay, so I have solved it in very much detail actually. And now coming to the next question. This is one more question that I have got from the information theory. And till now, I have got the easiest question possible from the information theory, because generally students are mug up with the Hamming code and they are very, yes, they are very tensed about that. If the question would have come from the topic like Hamming code, then it is difficult to solve for the many students, because it is a very new topic, newly introduced, and there are very less question asked from the previous year. So we don't get an idea that which kind of question could be asked. So if you have attended our vision batch, then you have got an idea that which kind of question can be asked from the information theory and coding part also. CRC, Hamming code, that also we covered in very depth in the vision batch. So these all questions we have already discussed in our paid classes. So I hope that the students, those who have joined the BYJU'S, they are able to solve the question from the communication and which was having very good weightage. So now the next question is, source transmits the symbol from an alphabet of size 16, the value of maximum achievable entropy. So this is very simple question from the information theory. The maximum achievable entropy is nothing but the log base 2m. Because from the concept, it should be always less than equal to log base 2m. M is the number of symbols. Here it is asking that the size of the alphabet is 16. So the h of x should be less than equal to log base to 16. So we can say that h of x is nothing but the 4-bit. That is the maximum value. The maximum achievable value of the entropy is 4-bit. It is asking in the bits. So the answer would be 4, right? The answer would be 4. Correct, Harshit? Okay, so the answer would be 4. Why you guys are saying 24? So now the Sanjay sir will come and he will join for his question. Sir, are you ready? So this is the question that sir will be discussing.
Hello students. Now there is a one question from analog. अगर आपके पास और भी है तो please send the questions. Now guys, that was given here. That particular capacitor in the figure is charged up to what, 10 volt when the switch was open, right? And then the switch closed at t equal to 0. So this switch is closed at t equal to 0. This is the 10 kilo ohm resistor. There is the one Zener diode, and that capacitor is charged up to what, 10 volt. So what is given here? The total energy dissipated in ideal Zener diode. Total energy dissipated in ideal Zener diode after the switch is closed in millijoule up to what, 3 decimal places, guys. We have to find the energy in what, millijoule. तो ऐसे मैंने बहुत सारे क्वेश्चंस क्लास में सॉल्व कराए हैं. पावर कैसे निकालना है हर बार मैंने आपको बताया. तो चलिए इसको सॉल्व करते हैं पहले, राइट? अब यहाँ देखिए. Now first of all in this question, if you want to calculate the power, first of all you want to calculate the energy, then integration of that from 0 to infinity. You have to integrate it. Then what is the power here? Power you can calculate, that is P is equal to what, V into I. So what is the V here? What is the voltage across the Zener diode? That is the Vz. When the voltage across the capacitor is greater than or equal to Vz, that is the 5 volt, the Zener diode will allow the current. Once the voltage across the capacitor will reduce below 5 volt, Zener diode will not allow the current means what is the initial voltage across the capacitor? 10 volt. And what is the lowest voltage across the capacitor? Only 5 volt. Because when it is less than 5 volt, Zener diode will not conduct. So this is the final, this is the initial value and that is the final value. And you can also calculate the time constant, that is the RC. Now, Vz into Iz. This is the I is nothing but the current through the Zener diode when the switch is closed, guys. Now, this is the I and Iz. So you have to find the Iz. So what is the Iz? The initial value is 10 minus 5 upon 10. So that is the initial value of I. This is the voltage across the capacitor. This is the initial voltage across the Zener diode upon what resistor, that is the 10. You will get 1 by 5 by 2. This is the 5 by 10. That is the 1 by 2 milliampere. This is the initial current. And what is the final current? Final current will be 0. Why? Because that is the 5 minus 5. That current will become 0 and capacitor will, after that, capacitor will not discharge. So final value is 0. Now, what is the time constant? RC. RC is 10 kilo ohm, that is the 10 into 10 raised to power 3. And what is the value of the capacitor? 10 microfarad, that is given in the question. So 10 microfarad, 10 raised to power minus 6. And you will get 10 to the power minus 1 second. 3, 4, and 5, that is the 10 to the power minus 1 by 10 seconds. Now you can find the equation of the current. I is equal to I final minus I final minus I initial e raised to power minus t by tau. ओके अब यहां आ गया आपका, देखो ये है फाइनल वैल्यू 0 माइनस 1 by 2 e raised to power minus t 1 by 10 will become what? 10. तो ये तो आपको मैंने डायरेक्ट बताया था कि आप डायरेक्ट ये फॉर्मूला यूज कीजिएगा एग्जाम में, तो आपने यूज किया होगा e raised to power minus t by tau को. तो फाइनल वैल्यू, और ये आपके आगे 1 by 2 e raised to power minus 10t. That is the value of the current in milliampere. Remember, this is in milliampere. Now we have to calculate the energy. So what is the energy? 0 to infinity power. What is the power? Vz. Vz is 5. What is the current? 1 by 2 e raised to power minus 10t into 10 raised to power minus 3 dt. Integrate it. Then it will become 5 by 2. That is the 2.5 into 10 raised to power minus 3. Right, and what is the integration? Minus 10, and that is e raised to power minus 10t, 0 to infinity, that will be limit. For infinity it will become 0, for 0 it will become minus 1, and that's why minus minus it will become plus. It will become 0.25 into 10 raised to power minus 3, guys. Okay, so that is the value. Now it is a minus 2, sorry, this is in what? Millijoule. Remember, that is in what? Millijoule. So you will get the answer 0.250. This is in joule. And that's why, what is the answer? 0.250 millijoule, because answer is required in what? Millijoule. So that is from my side. Now, Rakesh. Acha. Rakesh sir, are you ready? Yes, please. So, guys, और भी कोई questions हैं आपको? Any doubts in this question? Then you can ask. Yes, please. तो आज सभी कमेंट्स बॉक्स में जरा बताइए क्या आंसर, आप लोगों का क्या आंसर आया था, क्या आप लोगों ने क्वेश्चन सॉल्व किया? बाकी डिजिटल के सभी क्वेश्चंस आप लोगों से बन गए? यस प्लीज. साकेत सर, कैसा है क्वेश्चन का लेवल, क्या लग रहा है आपको?
सर अभी तक तो देख के लग रहा है कि क्वेश्चन का जो लेवल है वो काफी ठीक ठीक है, मतलब मॉडरेट ही लग रहा है. और स्पेशली कम्युनिकेशन जैसे कोर सब्जेक्ट में अभी तक तो सर 3 क्वेश्चन अगर मैं काउंट करूं तो मुझे तो तीनों क्वेश्चन इजी लग रहे हैं.
ओके.
है ना. रैंडम प्रोसेस हो गया, रैंडम वेरिएबल हो गया. रैंडम वेरिएबल को अगर हम लोग कम्युनिकेशन में ही काउंट कर सकते हैं, क्योंकि जैसा मैं देख रहा था वेटेज एनालिसिस, तो मैथ्स में 1 मार्क्स ज्यादा जा रहा है. तो आई थिंक वो कम्युनिकेशन में ही आना चाहिए. तो यस, सो क्योंकि मैथ्स तो सर मैथ्स एप्टी तो 28 मार्क्स फिक्स है ना. तो इसमें मैं एनालिसिस देख रहा था तो 29 हो रहा था. तो मुझे लगता है कि आई थिंक इट इज द फ्रॉम द कम्युनिकेशन, मतलब उसको कम्युनिकेशन में ही वो लोग काउंट करके पूछे हैं, क्योंकि सेंट्रल लिमिट थ्योरम अप्लाई हुआ है उसमें.
ओके.
सो सेंट्रल लिमिट थ्योरम के बेसिस पे उसको सॉल्व करके अगर हम बोले तो रैंडम वेरिएबल। तो क्वेश्चंस तो काफी इजी लग रहे हैं कम्युनिकेशन के अभी तक। अब देखते हैं बाकी सब्जेक्ट के सर लोग बताएंगे। अभी तक आपको कैसा लगा सर जो आपने पेपर देखा?
अभी हम लोग ये क्वेश्चन था सर, एक जेना डायोड पे ये क्वेश्चन आया, ये मतलब आपको पूरा ही
हाँ।
कैलकुलेट भी करना है, इंटीग्रेटेड
lengthy है।
क्वेश्चन है, नेटवर्क भी है
हाँ।
और आपका एनालॉग भी है इसमें।
तो
क्या
multiple
मल्टीपल
concepts।
कॉन्सेप्ट है, लेकिन ऐसे क्वेश्चन सर आप अगर हमारा कोर्स कोई
Course-
देखेगा ना तो ये क्वेश्चन हमने सॉल्व कराए हुए हैं
Yes,
क्लास
yes।
में। और जो डिजिटल में भी एक एमएसक्यू आया है, वो तो आपको 15th को जो सेशन हुआ था एमएसक्यू, तो उसमें ही हमने इस क्वेश्चन को सॉल्व करवाया है।
हाँ।
राइट, तो वहां भी आप लोगों ने अगर एमएसक्यू अटेंड किया होगा तो कितने लोगों ने अटेंड किया सर, इसको कमेंट। यस,
0.025 लिखा है मिली जूल में, isn't it?
हाँ शायद 1/10 आपने, यस 0.250 मिली जूल आया भाई, 0.250 मिली जूल। आई थिंक यू हैव मिस्ड 1/10। यहाँ कहीं रजिस्टर की वैल्यू, हाँ ये आपने रजिस्टर की वैल्यू कहीं मिस कर दी होगी। ओके, तो वो थोड़ा चेक कर लेना, मैंने बोला भी था आपको अवॉइड करना। आई रोट 0.025 नितिन शर्मा। ओके चलिए, हाँ अब सर आएंगे और क्वेश्चंस लेके, जब तक हम लोग और सॉल्व करते हैं। और आप बताइए आपके बाकी और क्वेश्चंस बने डिजिटल के, पूरे क्वेश्चंस डिजिटल एमएसक्यू वगैरह आप लोगों ने सॉल्व कर लिया? हैव यू सॉल्व्ड ऑल द क्वेश्चंस फ्रॉम डिजिटल गाइस और एनालॉग? एंड व्हाट अबाउट द लेवल ऑफ द एनालॉग पेपर?
यही किया ना सर आप, ये वाला?
हाँ,
ये तो किया ना अभी।
हम्म, लेंदी पेपर, एक स्टूडेंट्स बोल रहे हैं सर
बहुत सारे
लेंदी।
स्टूडेंट्स हिंदी ही बोल रहे, ज्यादा
ये था, ये अगर आप एग्जाम में देखा जाए ना, इट विल टेक टाइम, बट इट इज अ वेरी ट्रिकी क्वेश्चन गाइस। अगर थोड़ा किसी ने लगाया होगा ना, तो इनिशियली वी हैव टू कैलकुलेट द करंट एंड देन क्विकली यू कैन कैलकुलेट द पावर अक्रॉस द जेनर डायोड गाइस। दैट वाज द मेथड, राइट। हर्षित 24, यू गॉट 24। अच्छा होगा आप तो किसी दूसरे क्वेश्चंस की बात करें। Usual analog was tough and lengthy. Okay. So, okay, we will solve more questions, guys. Stay tuned with us. We are going to solve more and more questions for you.
Guys, so you guys can tell about more questions that you can recall with the data that so that we can solve these questions. We are here to analyze the questions, give you the correct answer. EDC moderate but lengthy, analog tough.
2+1 means this is from COA, one is from digital.
Hello guys, welcome back. Welcome back to the session. Am I audible? Am I audible, visible to you? Please confirm. Please confirm, am I audible and visible to you? Analog part is little bit tough, but control system part is moderate. Chinmay Rai is saying this. Happens, yeah. ISC Bangalore generally focus more on analog and EDC. I expected this. Yeah, you are right. You are audible and visible. I'm audible and visible to you. So let me, by the time Rakesh sir is coming with some more questions, we still getting the questions. So by the time I'll give you the update here about subject level. In control system for 2024 this year, those who wrote the exam just now, there are 6 marks. Total 6 marks appeared from control system. 2 2-mark questions and 2 1-mark questions. Digital circuits, 10 marks. In fact, it is bit higher, from digital side. 10 marks is there. Out of that, 4 are 2-mark questions, and 1 is from digital and 1 is from COA. So it is rare to happen. Sometimes this combination also happens. And then going to electronic devices, 12 marks is there. Yeah, this is really making the difference, I guess. This is going to be the deciding this year, because generally EDC is going to be 8 marks or 10 marks maximum. That is a higher side, but this time 12 marks are there. That's really going to change the game. As I just told you, IISc Bangalore will focus more on electronic devices and analog circuits. Let's see the questions. I have not received any question from electronic devices or analog circuits so far from the students. Guys, if you have any questions, remember, please keep sharing us. We'll solve you if you find this is difficult or easy. Then signals and systems is 10 marks. Out of this, 4 are 2-mark questions and 2 1-mark questions. Communication systems are 11 marks this time. Analog is 10 marks. These two are going to be deciding this time, I can say, because 10 plus 12 is 22 marks only from these two subjects. Going to be this one. Networks is disappointing. Only 6 marks. Generally, higher than 6 marks will come. Electromagnetics also lesser than usual it is. 6 marks only have come. Engineering mathematics aptitude is as usual every time. It's close to 30 marks. So that is what the paper difficulty level and paper subject-wise distribution of marks is. So overall, if you can understand, these are the 4 subjects having higher weightage this year: communication, signals, electronic devices, digital, and analog. I can say these 4 apart from maths and aptitude. One thing I can say by seeing overall just clicked in my mind is signals and communication. Together it is around 20 marks, 20 marks plus it is. These two are linked subjects, connected subjects. Similarly, electronic devices and analog circuits are also connected subjects. Topics will be sometimes overlapping. So together it is more than 20 marks again. So digital is 10 marks, little bit higher side actually, I can say. But it is good for you that digital questions can be attempted by many of the students. Most of the students don't leave the digital circuit subject since it is easy and more of numericals and shortcuts available. So every student can attempt digital circuits. Overall, by seeing this, I'll say it is not regular paper, not a regular pattern. It is slightly different from the last 2 years what the pattern was. Having higher marks on these subjects, electronic device and analog circuits, is not regular happens. So that's fine. I guess you guys are having fun on answering this type of questions. And one thing I can say, if the paper is like this, more questions and difficult the paper is, then one thing can be sure that even at lesser marks, you will get the better rank. If the paper is easy, always, even you score higher marks, you may not get satisfied with the rank you get. But if the paper is tougher and the questions are like this, if students are saying that these questions are really tough, then obviously, even you score less, 60 marks also can give you a better rank than last year. Okay. Impedance from load side given ZO is 50 ohms, also reflection coefficient. Nitin, yes, if that question is correct, then I think it looks like incomplete, but Saket sir is working on EMT part. So he will be coming up with the answer there. Going to next part. Let's see the subject-wise weightage percentage. As usual, every time maths and aptitude is nearly 15 and 14%, nearly 30% it is close to. Electromagnetics is 6%. Networks is, just a second. Yeah, electromagnetics is 6%. Networks is 6%. Analog is 10%. Higher marks subjects I am just highlighting. Control systems is again 6%. Digital is 10%. Electronic devices is 12%. And signals and systems is 10%. Communication is 11%. This is the weightage of the subjects in the exam. 200 ohms, I think. Vikram, which question you are saying? Nitin's answer you are saying? Please, guys, by the time you check it. People are saying the apti questions are easy. Let us see, guys. Apti questions are being represented by Rakesh sir. So please wait for another a minute or two. Sir is on the way to check the questions. This is very important, guys. That's what I was just telling you, that this comparison with 2024, 23, 22, and 21. Let's compare these years about the weightage of the subjects. Control systems is more or less same. 6 this year, 7 last year, last year 7, and before that it is 8. Digital, that's what just I told you. Last year it was 8, but this year is 10. Before last year it is 11. So 9 to 10 marks is average. See, here is the difference. That's why I told electronic devices is going to change the game this year for electronic students, because every year it is somewhere 6, 7 or 8 marks. But this time 12 marks is electronic devices. Guys, this is shared by some of our students only. If this is not correct, please point it out so that we'll correct the data. Because we have also not seen the paper, original paper. It is came from the students. So we consolidated those inputs and expecting that this is correct. But if this is not correct, please ping us. Please message in the chat box so that we'll correct the data as well. But as of now, the data what we received is this: 12 marks from electronic devices is going to be significant. Signals and systems also 8, 6 and 8 were in 22-21. But in 23 and 24, you have significant jump in number of marks from signals and signals. That means signals and systems have got the more weightage. And then communication systems also. Earlier used to be higher in weightage, but this time got reduced. From last 2 years, it got reduced and increased here in this electronic devices and some other subjects. Then analog circuits was close to 9, 8, 10. That's what this is remaining same as it is. There is no much change in this. 1 or 2 marks every time will differ, not fixed thing happens. See, that's what I said. Networks used to be 8 marks every year. This time this is got reduced to 6 marks. Where these 2 marks are added, I think electronic devices has been added. Electromagnetics also last year was higher weightage, but usually it is 6 to 8 range. This is not surprising to me. These two are fine as usual, right? These two are as usual, 14 and 15. So this is the subject-wise analysis. Please, guys, if you have other information what we shared, then please tell us so that we'll correct it, because this is not the information from the original paper. It is from the memory, the students who wrote the exam and shared the information to us. Hope it is clear, guys. And this is what the comparison year-wise, if you see, maths and aptitude is always higher, 14 to 15 marks. And then the higher side is analog circuits. But this year, almost equivalent weightage for electronic devices. This blue color is for 2024, and red is for 2023, green is for 21, and yellow is for 23. So this year, higher side, this one, this one, this one, and this one. One more is there, right? This, the technical subjects. That's what if you remember, I was telling that maths and aptitude, if you select maths, aptitude, it is 29 marks, right? This year also, close to. Then go with this 1, 2, 3, 4, 5 subjects. So plus 5 subjects. If you are familiar with these 5 subjects, so how many marks? 10, 11, 21, 31, 43, 53. So it is 53 marks. So total is, this is 282 marks you will be able to attempt if you are familiar with only 5 plus 2 subjects. Out of 82, even if you can leave some questions or some questions are wrong, even if you can score 65 to 70 marks or 60 to 70 marks, in the previous slides I have shown, right? I have shown you. You can see, guys. This time also you can see this. Previous slides I have shown you. I'll show you once again. If you can score these many marks, see, you are in this range now. Now you are in this range, isn't it? 60 to 80. That means you will be below 200 rank. You will be AAR less than AIR less than 200 is possible if you just select 2 plus 5 subjects. This is the strategy I was every time telling everyone. Okay. Shubham is saying very simple paper. That's what the mixed opinion we keep getting from the students. Some students say it is easy. Some students say it is difficult. Some students say it is lengthy, moderate. That's why I wanted you guys to keep commenting. Pramanik Patel is saying मैं rank under 20 expect कर रहा हूँ. अच्छा, very good Priyank, very nice. Congratulations to you. All the very best for your future. Okay. Very nice, guys. Very simple paper. Shubham is saying. Okay. So this is how the thought process should be, guys. Even for the students who want to prepare for next year, 25 and 26. So go with this strategy. First, you be comfortable with the 5 or 6 subjects. Then you will be in the safe side. Then keep adding the subjects so that you keep adding the marks also. So that gives you best result. Let us see once again these marks analysis. If you guys have any question, please keep asking us. By the time, let's see how many are the MCQs, MSQs, NATs, and how the difficulty level is. By seeing these questions, what we received so far, and from the inputs we receive in the chat box, and through the students whom we are in contact, consolidating all this data, we have concluded that the paper is a bit higher, tougher side. So it's not, so suppose if I say this is moderate and this is tougher and this is easy, okay? It is not between easy to moderate, it is moderate to tougher side. So this side only it is, can be considered, okay? Yeah, Chinmay is also agreed that it is moderate to tougher. Agree. We also saw some of the questions. Some questions are lengthy. Just now, Saket sir also have seen some question. It is a bit lengthy only. Coming to the difficulty level as compared to last year, yes, it is difficult. Just now I was telling that even the weightage of the subjects is also not matching with the last year's. We can say it is a bit higher difficulty side. Aptitude section was easy. Many comments are also there. We agree and consolidated that. MCQs are 8 number. 8 number of questions are MCQs. Sorry, MSQs. Last year, Rakesh, you remember how many are MSQs?
Last year, I think they were not
Lesser than 8, right?
Definitely,
They're lesser.
around 3-4.
So you can understand that year by year the MSQs are also increasing. First year when it is introduced, there is no MSQ question from EC.
21 EC double kuch bhi nahi tha.
Kuch bhi nahi tha. But next year added few questions. But this year more questions from MSQs. NATs are 18 or more than 18 questions, and MCQs are more than 30 questions. So this is how the question distribution is. So please comment if this is to be updated. If this is not exactly correct, please comment us so we'll update the data. This is the information so far we have received. I guess you want to discuss a question?
Yes, I have 2-3.
Yeah, we just received another 2-3 questions. So sir will solve you those questions. By the time, if you have any queries, please keep asking us. And please also ask your friends and others, please share the questions. Unless we receive some questions, we can't solve them. So if you want to know the answers, we have to have the questions. So please share the questions. We'll keep doing it.
Yes. I have 2-3 by the time Saket sir or Sanjay sir has.
Yeah.
Okay. Yes, guys. So I have 2-3 more questions. Let's discuss that now. Okay. Already, I think 6-7 questions I discussed earlier. चलिए आते हैं question की तरफ. So what is that first question I have? Yeah, here it is. Okay. Here it is. So I do have a lossless transmission line. Electromagnetic से question आया है. This simple one only. A lossless transmission line with characteristic impedance Z0 equal to 50 ohm. Okay, is terminated with an unknown load. Terminated with unknown load. Okay, ji. ठीक है. Now, what else is given? Magnitude of the reflection coefficient mod K. Okay, is 0.6. Magnitude of reflection coefficient is 0.6. Okay. Okay, this is reflection coefficient. As one move towards generator, okay, from the load. from the load. Okay. What is the maximum value of? Okay. What is the maximum value of? Okay. Input impedance. Yes. Did you see the question? पहले rectify कर देंगे आप लोग मेरे को. What is the maximum value of input impedance? Magnitude. Magnitude. Okay. Looking towards the load. Okay. Looking towards the load. Okay. Is dash ohms. Come on, everybody. Okay, come on. So there is a 2x1 marks with NOT gate and respective propagation delay question. So I think that is repeated in EC for third time. Okay, you can, if you, Tejendra, if you have the exact question, please draw the diagram and share it to me. You can share it on the Telegram to me. Okay. Yeah, come on. Sequence using T flip-flop. Yes, Tejendra, come on. If you have the question, I request you. Yes, Vikram. 4, 1.6 by 4. Correct. Yes, correct, Vikram. Very correct answer. It's a simple one only. Come on, everybody. Come on, everybody. Okay, so if you have, please share it on the Telegram. Guys, any of you have any questions, okay, please share me on the Telegram with the diagram. Okay, already we have done, several questions. Okay, several questions, whatever we have received till now. Okay, but we have done multiple questions. Now, देखो, as one move towards the generator from the load. Okay. What is the maximum value of the input impedance magnitude looking towards the load? As one move towards the generator from the load, okay, what is the maximum value of the input impedance looking towards the load? But looking towards the load, ye dhyan rakhna. Looking towards the load. Okay, so that is why, if I take this particular diagram, okay, this is some unknown load which is not mentioned to me. Okay, there is some load impedance ZL, jo given nahi hai, and neither it's going to be required, don't worry. Okay, and there is a line having the characteristic impedance of 50. Okay, this is my generator side, this is my load side. Okay, now the load impedance is ZL, but as I move towards the generator, okay, take any point, and at any point, if I want to calculate the impedance looking towards the load, okay, this is the input impedance. Okay, we can calculate at any point on the line basically. Okay, now that input impedance, we know that it is a function. We know that it is a function of the distance from the load end. But they are asking what is the maximum value? Remember guys, ये direct question है. Whether it is 1 mark or 2 mark, can anybody confirm me? यहाँ पे लिखा नहीं है मेरे पास. Anybody? 1 mark or 2 mark question is it? Okay, what is the value of the Z in max? The value of the Z in max is always given by S into Z naught. It is always given by S into Z naught. Z in min is given by the formula Z naught by S. It is covered, guys. It is covered in the classes. Okay, 2 marks, easy. Agar class follow kiya hai, to it is easy then. Dreamer says 1 mark. Okay. Dreamer says 1 mark. Not required. Reflection coefficient angle not required. Okay. If you know these techniques. देखो, यहाँ पे क्या given है? What is the maximum value of input impedance? अब देखो, when you are given the mod k dear, what is the standing wave ratio? Okay, it is given by 1 plus mod k upon 1 minus mod k, and that is 1.6 upon 1 minus 0.6.4. So this is equal to 4. Standing wave ratio 4 hai. Standing wave ratio 4 hai. So if the standing wave ratio is 4, dear, what is the answer? 4 into 50, and your answer is 200 ohms. Achha, another question of Z in 1 mark. If this is 2 mark, this is really simple, provided you have the notes. Otherwise, you will keep solving. Okay, Z in. Okay, where it is maxima or minima, and that too it is NAT. It's not MCQ also that you try with the option. So guys, that's going to be lengthy even if you try to differentiate, because it's a function of the distance from the load end, but that's going to be lengthy. Maximum value of input impedance at any point the line on is always given by S into Z naught. Minimum is Z naught divided by S. Okay, if you know this, balle for you gets 2 marks easily. Chalte hain next question ki taraf. What is the next question I have in the pool is? What is the next question I have in the pool is? Chaliye. All right. Yeah, guys. So the function yt is equal to at plus b. At plus b e raised to the power minus 2t. Okay, is the CF. Okay, of which differential equation? It is the CF of which differential equation? It is the CF of which differential equation? There are 4 options given. Okay, but yeah, let's solve it up. Now, guys, you can, solve by the very simple method of CF itself. by the very simple method of CF itself. If you try any Laplace and all, I think that's going to be really unnecessary calculation. Okay, because this is of the form, okay, AT plus B, okay, e raised to the power minus MT. Condition is roots are real and equal. This is when the roots are real and equal. What is that equal root? M ka value 2 hai. Okay, so what should be your auxiliary equation, dear? Because m is 2 and 2, so m minus 2 ka whole square equal to 0. So your auxiliary equation, m is minus 2, na? Correct. E raised to the power mt, m is minus 2, sorry. E power mt likhte hain na? E raised to the power mt, so m is minus 2 and minus 2, तो m plus 2 का whole square basically. ठीक है, m plus 2 का whole square, तो m square plus 4m plus 4 equal to 0. If this is the auxiliary equation, what is going to be differential equation? Second derivative. M square comes for second derivative. M comes for the first derivative. The 4y dash plus 4y equal to 0. Of course, assuming it is a homogeneous differential equation, since there is no pi part, it's only the CF given. Okay, so there should be one of the option, d2y by dt square plus 4dy by dt plus 4y equal to the 0. Very correct answer, Vikram. Yes, G, done it. So simple question, guys. Till now, in the beginning, students were telling it is, maybe tough or lengthy. Maybe we can't say right now because we don't have all 65 questions, but the questions received till now, okay, the questions received till now are definitely looking to be easy. Okay, Tejinder, I'll check. Let me just complete one or two more questions and then I'll check it out for you. Okay, dear. So now there is one aptitude question. Mix kar rahe hain jo bhi aaya hai. There is one aptitude question. Okay, given that very basic property, okay, similar questions we have done in the class also. Okay, 1 upon log x to the base 2, 1 upon log x to the base 3, 1 upon log x to the base 4 is equal to 1. Is equal to 1. What should be the value of x? Baba, very simple. Okay, because 1 upon log x to the base 2 can also be written as log of 2 to the base x. Okay, you can invert and the number and the base will interchange. Okay, plus next will be log 3 to the base x. Similarly, next will be log of 4 to the base x. This is equal to 1. Now apply just the property log a plus log b plus log c because common base ho gaya yahan pe ab, that is base x is log abc. Log 2 into 3 into 4, okay, in base x is equal to 1. Okay, is equal to 1. And 1 can also be written as log of x to the base x. Okay, dono taraf likh sakte hain na? Okay, so we have log to the base x 24 is equal to log to the base x x. Okay, so x is 24. Yes, Ji. Simple question of aptitude. Simple question of aptitude. Simple question of the aptitude. Chalo. All right. Chalo. So now there is yet another question that I have with me. There is yet another question that I have with me. Okay. And once again, MSQ. I think 2-3 MSQs to already hum log kar chuke hain. Okay. So once again, MSQ. The question is, dear. Okay. There is a function f, which is a function of space and time x, y, z, t. Okay. And there is a vector u, okay, which is also a vector of space and time, that is x, y, z, and t. Okay. And you are given del f by del t plus del dot fu is equal to 0. Okay, you have to choose which of the options is or are correct. MSQ question है, पहले लिख दिया है मैंने. Okay, integral over a volume del f by del t dv, del f by del t dv, very simple question it is. Okay, is negative of the integral over the volume del dot fu dv. There is another option B, okay, which says that, okay, del f by del t dv, okay, now over some surface defined by the scalar function, maybe f equal to constant will define a surface. Okay, so this is definitely going to be wrong. Okay, is negative of the integral over a surface S. Okay, fu dot n cap ds. Okay, option number C, dear. Okay, integral over the volume del f by del t dv. You know, this is nothing. Once I show you all the options, you will understand it's on a very simple theorem. Okay, it is negative over integral over surface f fu dot n cap ds, and option number D, okay, integral over volume del f by del t dv is negative of integral over a surface del dot fu dv. Very simple it is, dear. Very simple. F is charge density. Acha, they have talked in terms of charge density. Okay, no problem. No problem. Whatever it is, then you can call it as EMT question or, whether you call it as, maths question. It's a basic property here. It's on a basic property. So क्या given है इसको अगर लिख लें एक बार. Okay, this is the main thing given. Del F by del T. Okay, this is what I think I've got from the students. Del F by del T. Then it may be del rho by del T. It may be that case if it is the charge density. Yeah. So del F by del T plus divergence del dot Fu is equal to 0. Okay, so definitely we have del F dot del T is equal to minus del dot Fu equal to 0. Okay, minus del dot Fu equal to 0. Okay, and now you can integrate both the sides. Let's do the volume integral both the sides. Del F by del T dV over a volume, okay, is negative of integral over the volume del dot Fu. ये तो केवल एक step हो गया ना, just applied the volume integral on both the sides. Zero क्यों आया? ठीक है. Now this clearly says that तो option number A तो आ गया है. Okay, option number A आ गया है. Now just an additional thing. Okay, you are doing the volume integral. You are doing the volume integral of a divergence of a vector, and you can think in terms of Tejendra, not B and D. No, it's not B and D. चलो अभी that's what I'm going to check it out now. नहीं वो integral over a particular f हो गया ना. No, ठीक है. So now one thing is that you're going to apply here is, okay, Gauss divergence theorem, primarily reverse of Gauss divergence theorem. Okay, and Gauss divergence theorem says that the surface integral of a vector is over a closed surface is equal to volume integral. Acha, maybe as per question paper. Okay, ठीक है. Maybe volume integral of the divergence of the vector. So there is a volume integral of divergence of the vector. So it should be equal to surface integral of, okay, minus यहाँ पे भी रहेगा surface integral of fu dot ds, and dot ds can be written as n cap ds. Okay, n cap ds. Okay, n cap ds, provided यहाँ पे closed होना चाहिए. I don't know whether options has closed or not. Let's assume closed surface or something may be given to you. Okay, maybe something given to you. Whether it is closed surface or not, you have to check it out. Okay, very important point to note here is closed surface होना चाहिए. Otherwise, the Gauss divergence theorem would not apply. Okay, otherwise the Gauss divergence theorem would not apply. Right? So it has to be closed surface integral. Okay, so I'm assuming it may be mentioned or not because this is exactly memory based question. Okay, chalo. Now, next question that I have is, chalte hain next question ki tarah. What is that next question? All right, just a moment. Okay, so another question from signal and system, dear. Okay. Okay, there are two waveforms given to you. A very regular question from signal and system, guys. Very regular question from signal and system. Okay, there are the two waveforms given to you. Okay, xt and yt. You have to relate the two waveforms and then you have to relate their Fourier transform. That simple question it is. Okay, what is that xt given to you? What is that xt given to you? This is 0. Okay, -1 and this is -1. Okay, this is minus 0.5. What is the yt given to you is -2 set 2. Okay, having the amplitude +1, and this is the origin. Okay. Question is, what is the yf in terms of xf? Correct, ऐसे कुछ था. What is the yf in terms of xf? Perfect, yeah, that is what is the question. Come on, everybody, let me know. Come on, everybody, let me know if you have done this or not. And if you have done this, what is the answer that you might have got? Okay, so dekho, first of all, we need to relate the xt to the yt. And, first of all, let's do the amplitude folding here. If you do the amplitude folding, then you get the amplitude +1. Okay, so dekho. First of all, I draw for you -xt. If I draw the -xt, it's going to be like this. Now you get +1 from -1 to 0. Okay, but the yt is centered at the origin. Yt centered at the origin. This is centered at -0.5. So first of all, now next what I'm doing is I'm doing the right shifting. Okay, -x of t minus 0.5. Right shifting is t minus 0.5. So because if I right shift, I will get the center at origin. Okay, and the points will be now right shifting ke baad -0.5 and this is going to be +0.5. Okay, minus 0.5 से plus 0.5. Done है? Minus 0.5 to plus 0.5. Okay, now the only thing is expansion. Okay, this is minus 2 से 2. Expansion by 4. Expansion by 4, dear. Expansion by 4. Okay, के लिए what you need to do is you have to replace t by 4. Expansion mod alpha less than 1. Okay, so minus xt minus 0.4. So you have a relation. Yes, dear, you have a relation, and the relation is y of t is equal to minus of x t by 4 minus of 0.5. Correct? Hai? Okay, minus xt by 4 minus 0.5. So what's going to be y omega? Okay, what's going to be y omega? चलो एक एक करके चलते हैं. If xt has the Fourier transform x omega, okay, then let us apply right shift. Again, the precedence rules. Let's start with the shifting first. So xt minus 0.5 will have the Fourier transform x omega e power minus j 0.5 omega. Okay, the time shift introduces the phase term there. Okay, now when I do the t by 4, okay, compression expansion in time will represent compression in frequency. Actual properties x alpha t करेंगे तो 1 upon mod alpha. Okay, so 1 upon 1 by 4 x of omega by 1 by 4. Okay, e power minus j 0.5 omega again replaced by omega by 1 by 4. Omega by alpha करते जाना है, and only difference is a minus here, so a minus here. Okay, so what's going to be y omega? Now this is yt. This is yt. So what is y omega? Minus of 1 upon 1 by 4 minus 4 x of 4 omega. Okay, e raised to the power minus j 4 into 0.5 e power minus j 2 omega. E power minus j 2 omega. Achha, I think it was in terms of f. Okay, so omega ko 2 pi f rakha, so y is a function of f eventually. That can be written as minus x of 4f e raised to the power minus j 2 omega. Omega is 2 pi f, so overall 4 pi f. Minus 4x 4f e power minus j 4 pi f. You can check. Okay, you can check. Let me just, remove the pole from here, and so that I can see. Yes, done it. Chalo, good, Dave, if you did this. Okay, chalo. So now this is what is the question I had. Next one. All right. Okay, so one more question I have here. Okay, one more question, and I told you this is expected for EC provided IIC Bangalore is going to conduct. Okay. The vectors, okay. The vectors 2, minus 3 and a, comma, 3, minus 1 and 3, comma, minus 1, sorry, 1 and minus 5 and 7, okay, okay, form a basis, okay, form a basis of R3 definitely. Okay, what is the value of A in that case? Form a basis. Just rectify. Just rectify. There is a question from complex variable also. Guys, whatever extra questions you have, just share me in the Telegram. I will keep checking once I am done with this. I'll open the Telegram. Come on, everybody, keep sharing this with me. Yes, dear. Chalo. ठीक है, done है. So to form a basis, what should happen, dear? Okay, to form a basis, vectors form a basis. That means, confirm me whether this question is there or not. Hello? सर आप लोग रेडी है कुछ? ठीक है, ये अभी फिलहाल मेरा लास्ट क्वेश्चन है, मैं आपको जूम पे से चालू रखिएगा. Okay. Yes, guys. Rishikesh say vectors don't form a basis. Okay, then only we can find the value of A, because if they form a basis, A not equal to something will come. A not equal to something. So what they are telling, guys, can you tell me? They are telling to form, they do not form a basis. अगर ऐसा करना है, okay, they do not form a basis. Okay, to form a basis, they are linearly independent. Okay, so do not form a basis. Okay, क्या बोला है? They do not form a basis. Okay, that means they are linearly dependent. Acha. That means they are linearly dependent. So what I do is normally let me take a simple matrix A. Okay, and in the matrix A, let me arrange the vectors x1, x2, x3 as the columns of the matrix and maybe the rows of the matrix. So if they are dependent, okay, if they are dependent, that means the columns of the matrix are dependent. And for such a matrix, the determinant is 0. Whenever rows or columns of a matrix are dependent on each other, determinant of the matrix is 0. Okay, so, if you have dependent columns, this is the simple way to solve. If you have dependent columns, mod A equal to 0. तो केवल एक calculation करना है. What is the value of mod A? What is the value of mod A? 2 minus 3 and A. Let me write down the numbers 2 and minus 3 and A. चलो यहीं से लिख देता हूँ बार-बार. Okay, what is that next number? Okay, 3 and minus 1 and 3. Perfect. And 1 and the minus 5 and the 7. Okay, equal to 0. चलो. So what's the answer going to be? 2 minus 7 minus minus plus 15 हो गया. Minus of again minus 3, 21 minus 3 and plus of A, okay, minus of 15 minus minus plus 1 equal to 0. If they do not want to form a basis, this becomes 8, 8 2s are 16, okay, plus 3 and this is 18, 18 3s are 54, okay, and then minus 14A equal to 0. So the value of 14A is equal to 70 and A is hence equal to 5. Simple calculation, A equal to 5. Yeah, official answer key will be released by Gate Thomas. Okay. The value of A is 5. Come on, everybody, check it out. The value of A should be 5. The value of A should be equal to the 5. Come on, everybody. Chalo, guys. So now, yes, Sanjay sir and Saket sir are ready with some questions. I request Sanjay sir, if you can join us on the Zoom. Yes, come on, everybody. Okay, do not forget to share the session. Keep sharing the session, everybody. Okay, let all the students get the benefit. Yeah, here we have Saket sir with us. Okay, guys. So yeah, I'll be joining soon with some more questions.
So guys, we have one question from the communication again, and that is from the analog communication. Very easy one. स्टार्टिंग हो गया पूरा हट गया क्या मुझे दिखे थे दिखने लगा कुछ है ना हट गया Okay guys, so just wait for 1 minute. Means I'm writing the question. The question is from the communication, that is analog communication. Okay, so actually there was some problem, technical problem. So because of that, what the question which I had written is completely erased. So let me find the question. Yes. So the question is from analog communication, that is from the topic amplitude modulation. And the question is, we have an amplitude modulated signal. We have an amplitude modulated signal. Okay, that is your S of t. This is S of t is equal to A cos 400 pi t and B cos 360 pi t and again B cos 440 pi t. Okay, so this is the amplitude modulated signal. We know that this is the standard form of the amplitude modulated signal, and it is also given that we have the normalized carrier power. Okay, so the normalized carrier power is also given. So normalized carrier power is 50 watt because the resistance is given as 1 ohm, and the ratio of sideband power to the total power is given as 1/9. Ratio of sideband power to the total power is given as 1/9. Yes. Okay. So guys, because it is given that we have to find the sideband power to the total power ratio, because this is given and we have one unknown factor, and the carrier power is also given. So if I find this carrier power, which is nothing but the carrier amplitude, that is the amplitude of the carrier is A cos 400 pi t, because these two are having the same amplitude. That means it is nothing but a lower sideband and the upper sideband. So this is our carrier. So the amplitude is square divided by 2. So A is equal to 2 times of PC and root over it. So this is 2 times of 50 root over it. So it is 10. So the value of A is 10. The value of A we have got 10. Now we have to calculate the sideband power. Okay, what is the sideband power? The sideband power is nothing but the B square, that is amplitude square, by 2 for the lower sideband, B square by 2 for the upper sideband. So it is B. So what will be our total power? The total power will be the carrier power plus sideband power, right? So the carrier power was that is 50, which is already given, and the sideband power is B, that is given. Okay, now the ratio of, from here, the ratio of the sideband power, that is B upon 50 plus B, is equal to 1 by 9. Okay, so this is 9B equal to, okay, this is 9B equal to 50 plus B, right? So we have got 8B is equal to 50. Okay, amplitude is square divided by 2. So sorry, this is B square. Okay, so this is B square. B square by 2 plus B square by 2 is B square, and this is also B square. So this is B square and B square. So we will get 9B square and 50 plus B square. So we will get 8B square. So B square is equal to 25 by 4. So B is how much? 5 by 2, that is equal to 2.5. Okay, this is 2.5. So we have to calculate the value of B, which is coming as 2.5. So this is our answer. Okay, we had to find the value of this constant B, that is the amplitude of the sideband, which is very easy question, because this type of question we have already solved in our vision batch. Because here in the question, if you can recall, there was a question which is written in the form of M and N, that if it is written in the form of M and N, the transmission efficiency was given, and this is nothing but a transmission efficiency also only. In the question which we have solved in our vision batch, I have given in you as a transmission efficiency. In the same question, it was M and it was N and N, and I have given you the carrier power and the transmission efficiency. It is also given as the carrier power and the transmission efficiency. They directly not given the transmission efficiency, but they have given in the form of ratio, which is the sideband power to the total power, which is nothing but the transmission efficiency. And the same question we had already solved. So in this way, you can solve this question. And now the Sanjay sir will come with the question of, I think, analog, network and analog both.
Okay. Now there was one question from what network, guys. Okay. So what is the question here? I think that is the question. 5 milliampere current, 1 kilo ohm, that is the 1000 I naught, 1 kilo ohm, 2 milliampere, and that is the 1 kilo ohm. So guys, यहाँ पर ना थोड़ा सा, अगर this is a numerical answer type question, NAT, be careful about this. Right, this is the voltage source. It is a current controlled voltage source, right? This is a current controlled voltage source, and then this is called alpha I naught. Alpha I naught. So alpha is given as 1000 I naught. So what is the unit of the alpha here? That is not mentioned in the question, I think. If that is not mentioned in the question, means what? This 1000 is what? Normally, it is what? Volt per ampere. Volt per ampere. Right, that is the unit. So then that's why we are getting this is in what? Volt. This is in what? Volt. Means you have to take I naught in what? Ampere, guys. Right? That is the case. So if suppose we want the current in ampere, then you have to convert it into what? First of all, you have to convert it into what? Be careful about that. You can convert it into 1000. Right? First of all, this is the 1000 ohm. This is the 1000 ohm. This is the 1000 ohm. And that is milliampere is converted into what? Just to avoid the calculation mistake. Otherwise, I will give you the shortcut also. 5 into 10 raised to power minus 3. And this is what? 2 into 10 raised to power minus 3. That is converted into ampere here. Right? Now, watch this. What is this current? I naught. Right? So, according to the KCL, if this is the 5 into 10 raised to power minus 3, then what is the current here? 5 into 10 raised to power minus 3 minus I naught. I naught is also in ampere. Now, this is the current. Now, what is the current here? 2 milliampere. 2 into 10 raised to power minus 3. So what is the current here? 5 minus 2. That will become 3 into 10 raised to power minus 3 minus I naught. That will be the current in this branch. Okay. Now we have the current, and remember we can apply the KVL across this loop, right? We can't, sorry, that is not the loop. We can't apply the KVL with the current source. So this is the loop. Okay, this is the loop. Now write down the KVL here. When we are writing the KVL, it will become, this is the plus, this is minus. You can write here. Remember, this is again the 1000 ohm. I'm just saying that this is the 1000 ohm. So it will become, this is the plus, this is minus, because it is downward. So this is the plus, this is the minus. So it will become minus 1000 I naught. Remember, I naught is in ampere. Then it is what? Minus 1000 I naught. Check my calculation also. This is the minus 1000 I naught. This is the minus 1000 I naught. Now in this path, it will become plus 3 into 10 raised to power minus 3 minus I naught into what? 1000 is equal to what? 0. Is it clear? That is the 5 into 10 raised to power minus 3, and that is the 2. That's why it will become what? 5 minus 2, that is the 3. And now finally apply the KVL in this loop. When we are applying the KVL, it will become minus 1000, and this is the minus 1000. So I think this is the minus 3000 I naught. Check this. Okay. And on the right hand side, when it is multiplied with the 1000 into that 1000, and this is cancelled, this is the 3 plus 3 is equal to 0, guys. Okay. Now, what is the I naught is equal to 3 by 3000 ampere. That is 1 by 1000, that is the ampere, and that is calculation after calculation, you will get the nearly equal to 1 milliampere. So check my calculation, guys, but you have to, in this question, we have to take care of what? This portion, 1000 I naught. Normally, what we are taking it as what? Milliampere, and simply we are doing the calculation I naught in milliampere. This is in register. Then there may be the problem, guys. It is a numerical answer type question. That's why if they are giving different answer, then that will become what? Numerical answer, MAT type, matlab MTA type, marks to all. Why? Because simply that unit of alpha is not given. Right? Now, what is your response, guys? तो आपका क्या आंसर निकला है, जरा देखें. यस प्लीज, जरा इसका आंसर बताइएगा. ओके, तो आ रहा 1 मिली एम्पियर आप लोगों का भी. चलो अब आते हैं दूसरे क्वेश्चन में. एक एनालॉग का क्वेश्चन है मेरे पास, उसको हम लोग सॉल्व करेंगे. वन क्वेश्चन फ्रॉम एनालॉग. हाँ, तो ये है अनदर क्वेश्चन ऑन एनालॉग, गाइस. That one oscillator is given with non-inverting operational amplifier. Non-inverting operational amplifier, guys. This is R naught, this is R, and that is ground. Now there is a one feedback path. This is the standard circuit. That is the high pass. This is the high pass followed by what? Low pass. They will provide the same phase shift. That's why the total phase shift will become 0, and the Barkhausen criteria is satisfied, guys. Now here, this is the ground. Here we are taking the feedback, and that is connected to what? Non-inverting terminal. So this is a basic amplifier. First of all, this is the basic amplifier, and second, this is the beta network. We are sampling the voltage here, V0, and we are mixing the voltage here, VF, and when the VF is equal to what? VI, then Barkhausen criteria will satisfied. You have to find the beta and then make the imaginary part is equal to 0. So this is the beta part. This is the VF and it is the V0. You have to find the beta. What is the beta? VF by V0. Beta is VF by V0. Right? Then second Barkhausen criteria, you will get, first of all, make the imaginary part of beta 0. Then you will get the frequency of oscillation, that is omega 2 pi f0. And second part, mod of A beta should be equal to what? 1. And you will get the condition for oscillation. So what is the A for this circuit? A for this circuit is 1 plus RF by R1, that is R0 by R. Yeah, that is the gain of non-inverting operational amplifier, and that is the lengthy part. If you have the standard answer for this portion, then you can easily solve. Right? In my class, already I have solved. You are getting the beta is equal to what? 1 by 3. How I am going to give you, but already in my class, please watch my workbook. Same question I have solved. Right? Same question I have solved 2 to 3 times, and that is the with FET. Same logic with FET. So simply focus on this. This is R, this is C. Right? And this is the VF. Remember, this is the VF and this is the V0. Directly you can apply here. Just watch this. This is the VF plus minus VF because it is AC signal. Now you can put here 1 by SC. This is R, 1 by SC. Now how you can find the VF by V0? Simply you can apply the Cramer's rule. So yeah, or mesh analysis, like this is I1, this is I2. Right? Very, very simple. Now write down here. You can write inspection method R plus 1 by SC minus I2 into R, and that is equal to what? V0. This is the first equation. Second equation, now this is the minus R into I1. This is the common, and R plus R, this is the 2R, this R, that R, and 1 by SC into I2, that is equal to 0. Now, what is the matrix here? R plus 1 by SC minus R, 2R plus 1 by SC, I1, I2 is equal to V0 and 0. Okay, now we have to find what I2. Why? Because I2 VF is equal to what? 1 by SC into what? I2. So you have to find the I2 only, right? Because then we will get the VF upon V0. So if you, what is the del here? First of all, find the del. So del will become R plus 1 by SC into 2R plus 1 by SC, right? R plus 1 by SC into 2R plus 1 by SC, and this R minus minus plus, and again it will become minus. That is the minus R square. Okay. Now it will become, this is the multiplied with SCR plus 1 upon SC into 2 SCR plus 1 अपॉन SC माइनस R स्क्वायर. तो देखो यार, ये तो क्वेश्चन ही इतना लेंदी था अगर इसको सॉल्व कर रहे हो, लेकिन मैंने क्लास में इसको अगर सॉल्व कराया, आप शॉर्ट ट्रिक लगाते तो तेजी से सॉल्व हो जाएगा ये. अब ये SC आपने कॉमन ले लिया, तो इसे आप मल्टीप्लाई कर दीजिए, तो ये आ जाएगा आपका 1 प्लस SCR प्लस 2 times of S square, C square, R square, check my calculation also, 2 times of that, and plus 2 SCR minus S square, C square, R square upon S square, C square. And guys, that is the value of what? Del only. Now you have to find the value of del 2 only. That is the del 2. What is the del 2 here? Del 2 will become, this is what 0, and you have to put the 0 and V0 here. R plus 1 by SC minus R V0 0. So what is the del 2 here? That will become 0. This will minus minus, it will become plus R V0. So what is the I2? Del 2 by del. राइट तो यहां से आप कैलकुलेशन मिस्टेक भी थोड़ा अवॉइड कर सकते हो. दैट इज द del 2 by del. तो ये जो गया ऊपर आपका, राइट, और यहां आ जाएगा S square, C square, R V0 डिवाइडेड बाय, दैट इज 1 plus 3 SCR. This is the, and this is minus, so it will become minus S square, R square, C square. Okay, and that is the value of I2. But we have to find the VF. What is the VF? 1 by SC into I2. 1 by SC into I2 means what? VF is equal to 1 by SC into I2. So this SC and that SC will cancel. SCR V naught divided by 1 minus S square R square C square plus 3 SCR. Now you can get the beta. Beta is equal to VF by V naught is equal to, this is SCR upon 1 minus S square R square C square plus 3 times of SCR. अब बताइए ये इतना कैलकुलेशन एग्जाम में पॉसिबल है क्या? बहुत ही लेंदी है ये, लेकिन चलिए ये हो गया अब सॉल्व. अब यहां पर रख दीजिए S इज इक्वल टू जे ओमेगा, राइट. देन इमेजनरी पार्ट को आपको जीरो करना है, तो दिस इज द जे ओमेगा आर सी अपॉन 1 माइनस जे ओमेगा स्क्वायर आर स्क्वायर सी स्क्वायर, दैट इज जे जे विल बिकम -1. दिस एस स्क्वायर -1 प्लस जे 3 ओमेगा आर सी. Now you can multiply j upon j, so it will become minus omega rc upon j 1 minus omega square r square c square minus 3 omega rc. अब देखिए इसको इमेजनरी पार्ट को जीरो करो तो आपको मिल गई फ्रीक्वेंसी ऑफ ऑसिलेशन, दैट इज इक्वल टू 1 बाई आरसी, दैट इज इक्वल टू 1 बाई आरसी. और यहां जो बच गया ये टर्म, ये माइनस कैंसिल हो गया, एंड देन बीटा विल बिकम व्हाट 1/3. Then mod of A beta should be equal to what? 1. So what is the A is equal to 1 by beta? That is nothing but 3. And what is the A? 1 plus R naught by R is equal to 3. So what is the R naught by R is equal to 2. So what is the R naught is equal to 2 times of R. So R naught is equal to 2 times R. That is the answer for this question. 2 times of R. That is the answer for this question, guys. तो यहां से दो क्वेश्चन हो गए. That is one question from what analog and one question from what network. अब तो अभी और भी क्वेश्चंस हम लोग लेकर आएंगे, राइट. तो आप लोगों के आंसर्स क्या हैं भाई, जरा बताना. आप लोग भी कमेंट्स में दीजिएगा कि क्या आपके आंसर्स हैं गाइज. यस प्लीज. आंसर 2 R एंड यस आपके भी आंसर आ गए. एंड यस आई एक्स वॉज 1 मिली एम्पियर ना, तो आपने यहाँ पर आंसर तो दिया है 1 मिली एम्पियर. आई नॉट दे आस्क्ड टू फाइंड आई एक्स अक्रॉस 2 किलो ओम रजिस्टर. अच्छा 2 किलो ओम रजिस्टर के अक्रॉस पूछने बोला है, तब भी आपका कैलकुलेट कर लीजिएगा वैल्यू, राइट. अच्छा क्या, एक मिनट रुकिएगा, क्वेश्चन में क्या प्रॉब्लम है जरा. ये तो 1 किलो, वेयर इज द 2 किलो ओम रजिस्टर? Where is the 2 kilo ohm resistor? If there is a 2 kilo ohm resistor, then okay, you can change the values, but calculation will remain same, guys. Part of calculation, right? तो उस हिसाब से आपका आंसर चेंज हो जाएगा. ये देखो मेरे पास जो डेटा है, अकॉर्डिंग टू दैट, दैट इज द वैल्यूज 1 किलो ओम, 1 किलो ओम एंड 1 किलो ओम. ओके. इसका नहीं, ये डेरिवेशन की सुरजीत, डेरिवेशन की नीड नहीं है. ये तो मैंने क्लास में ऑलरेडी सॉल्व कराया ना आप लोगों को, कि सीधा सीधा 1/3 आप निकाल लीजिए और दैट इज द आंसर. 1/2 pi RC is the omega naught, and beta, the value of the beta is what? 1/3. That is the high pass filter followed by the low pass filter. That's why the total phase shift provided by the beta network will be 0. Right? Beta network will be 0, and what is the phase shift provided by the basic amplifier? 0. And that's why bar question criteria satisfied. Bar question criteria will satisfied. Okay. तो ये यहां से ये क्वेश्चन हो गया आप लोगों का सॉल्व. अब और कोई डाउट है इसमें तो आप लोग पूछ लीजिए जरा. अच्छा आप लोगों ने सॉल्व कर लिया था ये क्वेश्चन, क्या आया था आप लोगों का आंसर? सेम आंसर आया था. कितने स्टूडेंट्स ने इसको सॉल्व किया था भाई? यस प्लीज. So following through the following through the 1 kilo ohm in the last. Okay. Okay. अच्छा, एक मॉस्फेट किस पे आया था? मॉस्फेट पे वोल्टेज गेन का क्वेश्चन आया था। ओके, तो उसको हम लोग देखते हैं कि कौन सा क्वेश्चन है। अगर वो ग्रुप में आ रहा है तो मैं उसे फिर सॉल्व करते हैं। राइट, या आई थिंक दैट इज क्लियर टू यू। ओके, तो यहाँ पर आप चेक कर लीजिएगा। तो ये ऐसे सॉल्व करना था। एंड देन ये एनालॉग का क्वेश्चन था। ये स्टैंडर्ड है, इस एग्जाम हॉल में इस तरीके से सॉल्व नहीं कर सकते, अदरवाइज ये मैथ एनालिसिस से बहुत ही इजिली सॉल्व हो जाता है विदाउट एनी मिस्टेक। और जैसे भी आपको निकालना है वी एफ बाई वी नॉट निकाल के उसको जीरो कर लीजिए। ओके, तो अच्छा, तो और भी आप लोगों के कौन से क्वेश्चन है? ओवरऑल पेपर आप लोगों को कैसा लगा? कितने मार्क्स आ रहे हैं आप लोगों को? क्या गेसिंग है कि क्या पेपर मॉडरेट था कि टफ है कि इजी है? अच्छा, किन 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 लोगों ने एमएसक्यू ज्वाइन किया था? एमएसक्यू का अभी हम लोगों ने एक सीरीज ली थी एमएसक्यू, आप लोगों ने ज्वाइन किया था? टफ। ओके, योर अच्छा, अकॉर्डिंग टू यू दैट इज टफ। अच्छा, कितने लोग हैं जो जिन्होंने इंस्ट्रूमेंटेशन से पेपर दिया है, या फिर आप इलेक्ट्रिकल देने जा रहे हैं भाई, इलेक्ट्रॉनिक्स वाले? इलेक्ट्रॉनिक्स गाइस, यू आर गिविंग द गेट नेक्स्ट पेपर or not giving? Computer science you have choice, instrumentation or what, electrical or what, क्या data science and artificial intelligence, four, 3 or 4 options। और नेटवर्क में और कोई क्वेश्चंस आए थे आप लोगों के? नेटवर्क के क्वेश्चंस कैसे आए थे? दैट इज द मॉडरेट और टफ और इजी क्वेश्चंस फ्रॉम नेटवर्क। तभी क्वेश्चन सॉल्व हो गए, दैट इज फ्रॉम नेटवर्क। I think there was one more question. और भी आप लोगों के पास कोई क्वेश्चन या? ओके, सर आ रहे हैं तो आप लोग यहीं रहिए। राकेश सर और भी क्वेश्चंस लेकर आ रहे हैं आप लोगों के लिए। दैट इज द क्वेश्चन फ्रॉम व्हाट एप्टीट्यूड एंड क्वेश्चन फ्रॉम व्हाट मैथ्स एंड वेरियस सब्जेक्ट। ओके, जब तक आपके पास कोई क्वेश्चंस है तो वो आप सेंड कर सकते हैं। आप क्वेश्चन सेंड करते जाइए, सॉल्यूशन बनता जाएगा, और आप अपने आंसर्स को भी वेरीफाई कर सकते हैं। यू कैन सेंड अस क्वेश्चन ऑन अवर टेलीग्राम चैनल, राइट, और ऑन कमेंट्स बॉक्स। I think there was a one question from current mirror circuit also. तो इसको भी वन मॉसफेट क्वेश्चन आई थिंक। नेटवर्क सबसे इजी था। ओके विक्रम, तो जैसा हम लोगों ने नेटवर्क में पढ़ा वैसा ही आया क्वेश्चंस। मैंने कहा भी था ना कि क्वेश्चन को आपको डिसाइड करना पड़ेगा वेदर इट इज इजी, मॉडरेट और व्हाट, टफ। और अगर आपको एनालॉग टफ है तो ठीक है, नेटवर्क इजी आया तो नेटवर्क से आप लोगों ने बनाया होगा। लास्ट में साकेत सर ने, मैंने, राकेश सर ने, ईशान सर ने आप लोगों को टिप्स दी थी कि पेपर को कैसे डील करना है, राइट। अगर आपको सब्जेक्ट वाइज देखना है कि वेदर इट इज इजी और मॉडरेट और व्हाट टफ, नेटवर्क फाइन, एनालॉग वाज टफ, नेटवर्क सबसे इजी था। ओके ओके, वॉट एवर द क्वेश्चंस दैट आर इजी, वेरी इजी, एंड रेस्ट आर वेरी टफ। ओके गाइस, अच्छा, मैक्सिमम पावर पर भी क्वेश्चन आया है। अभी तक मुझे, मेरे पास वो क्वेश्चन नहीं आया गाइस, उसको क्वेश्चन को सॉल्व करके हम लोग आपको देते हैं। देखो एमएसक्यू का वेटेज भी बढ़ता जा रहा है। अच्छा एक बात बताओ, 1 मार्क्स एमएसक्यू थे, ऑल आर ऑफ 2 मार्क्स ना, तो 8 क्वेश्चंस आ गए फ्रॉम मल्टीपल सेलेक्ट क्वेश्चन गाइस। मल्टीपल सेलेक्ट आंसर, ये वेटेज धीरे धीरे बढ़ेगा, जैसे एनएटी हो गया आपका, एमसीक्यू हो गया और आपका एमएसक्यू नाउ। लास्ट ईयर थोड़े कम और धीरे धीरे आपके इसका जो वेटेज है वो बढ़ता जाएगा। I think 1 or 2 questions from MOSFET, na? In analog as well as in EDC. 1 or 2 questions from MOSFET. आप लोगों ने भी ऐसे ही कैलकुलेशन की थी या फिर कैसे सॉल्व किया इस क्वेश्चन को सर?
So guys, we are waiting for the Rakesh sir to join, and till then we can discuss whatever you want to ask. You can ask about the what are the different things. If you suppose your paper is not gone well, then also we can discuss over that. How did you find it? Because actually we have already solved many questions up till now, and as far as we have seen from my subject, I can say that question paper is looking easy. But from the EDC, I think there is no question we have received. So if you guys can share any question from the subject EDC, then you can share. So yes, Rakesh sir is here, and now he will solve the more question for you. Thank you, Rakesh sir.
Yes. Yeah, thank you, sir. So guys, here we do have some more questions coming up here. Okay, students are sharing on the Telegram. So देखिए, yeah, चलो. So starting with the aptitude question. Okay, starting with the aptitude question, I do have a question here. I have aptitude, I have a question from digital, I have a question from controls, I have a question from signals also. DFT का एक बढ़िया question है. Okay, so 3 power 199 minus 3 power 196. Okay. Okay. What is the maximum, what is the greatest prime factor? ये बोला है. What is the greatest prime factor of this number? Come on, very simple question. Come on, yaar, very simple question. What is the greatest prime question? Yeah, digital ke one or two questions I think from digital we have solved. I think I have 2 more. In one of the digital questions, I don't have the complete data. Okay, but yeah, you can help me out with me. So guys, what is this? 3 power 196 is common, and then you are left with 3 power 3 minus 1, and this is 3 power 196. All right. Okay, now 3 power 196, the prime factor will only be 3 because it's a multiple of 3. It's a 3 power 196 case divided in multiplied by 27 1 minus 1, that is 26. So this is 3 ki power 196 is multiplied by 13 is multiplied by 2. Simple answer, na? No. Highest prime factor is not 3. Highest prime factor is 13. 13 also is a prime factor, na? 13 also is a prime factor. 26 is factorizable as 13 into 2. Okay. It is factorizable as 13 into 2, and 13 is the greatest one. The greatest is 13. Okay. The greatest is 13. Correct, Chinmoy. Okay. Even the options are like this. There options be given. Aapko options given hai 2. Option is given to be 13. Option is given to be 3 also. Option is given to be 11 also. Simple hai, guys. Okay. Simple hai. Done hai? Chalo, next question then. If this is done, let's have the next question then. So what is the next question, guys, we have? What is the next question we have? All right, let me see. Yeah, here we have another question here. Mathematics hai ye. Okay, integral, okay, for sine 2 pi z. Integral sine 2 pi z upon z square z minus 2 dz. Upon z square z minus 2 dz. Mod z equal to the 3. I told you for EC, complex is very important, and there is always a question from complex in EC. Okay, simple one hai. Mod z equal to 3. Acha, if mod z equal to 3, let's look into the poles here. What are the poles here? The poles are z equal to 0, 0, and 2. Okay, and all are inside. Okay, all are inside. Very clearly you are able to see that all are inside. Okay, mod z equal to 3. For all of them, magnitude is less than 3. That means they are inside the given circle. That means they are inside the given circle. Okay, तो सभी का रेसिड्यू निकालेंगे. Okay, now this is a pole of order 1. This one is a simple pole. This one is a simple pole. So what is the residue corresponding to the simple pole? It is limit z tending to a, that is z tending to 2, z minus a. Okay, fz. Okay, z minus a, fz. Fz is sine 2 pi z upon z square z minus 2. So z minus 2 the cancel हुआ, put down z equal to 2. Okay, the sine 2 pi into 2 upon 2 square, but sine 4 pi is 0. Sine 4 pi is 0. ये question finish हो गया. This residue is not required. Okay, now if you want to talk about this one, okay, this is a pole of order 2. Okay, this can be a pole of order 2. Okay, so let me write down what is my fz na. My fz here is sine 2 pi z. Okay, upon z square z minus 2. Let me write it like this. Upon z minus 2 whole divided by z square. I'm talking corresponding to the term pole z equal to 0. And now let's say this function fz is nz upon z minus a power m. Okay, for the pole of order m, the residue is given by what formula? Okay, the residue corresponding to the z equal to 0 will be given by the formula nm minus 1a. Okay, nm minus 1a. Yeah, ये कुछ hang करने वाला है, I know. Okay, so residue corresponding to z equal to 0 will be given by the formula nm minus 1a upon factorial m minus 1. Okay, m का value 1 है, sorry 2 है, pole of order 2 है, and a, the location of the pole is 0. So this becomes n2 minus 1, that is n dash. It's m minus 1th derivative, so it will be only first derivative, n dash 0 upon factorial 1. Factorial 1 is 1. So what you need is n dash 0. Now what is the n dash 0? निकाल लेंगे guys. If you have solved, do let me know, and let me close this poll, guys. I'm not able to see. Okay. I'm not able to see now. Now I am able to see the comment box. So do let me know if you have solved it. So what is the value of nz? Okay, that is basically sine 2 pi z divided by z minus 2. इसको separate करके. Sine 2 pi z upon z minus 2. Now what is the value of n dash? The first derivative is only required and hence it's going to be simple. Okay, this looks like z minus 2 ka whole square. Okay, z minus 2 constant, differentiation of sine 2 pi z will be 2 pi cos 2 pi z minus of, okay, minus of sine 2 pi z constant, and then if you take the derivative of z minus 2, that's going to be only 1. Okay, now what is the value of n dash 0? Okay, z equal to 0, so minus 2 into 2 pi into cos 0, okay, minus sine 0, okay, divided by minus 2 का whole square. बताइए, तो this becomes minus 4 pi. Minus 4 pi cos 0 1 sin 0 0 divided by 4, 2 ka square 4. So this is minus pi. This is minus pi. Correct? Eh? So what is the answer then? The value of the integral as per the Cauchy residue theorem is 2 pi into summation of the residues. Summation of the residues. So 2 pi I. The first residue turned out to be 0. Second kitna nikala humne? That is minus pi. The second one is equivalent to the residue, which is minus pi. So the final answer is minus 2 pi square I. Check out your answer, dear. Minus 2 pi square I. Minus 2 pi square I or 2 pi square j. Correct. Rahul says it is only sine pi z. Maybe. See, this is data is memory based. If the data is sine 2 pi z, then this is your answer. Then this is your otherwise slightly it will change. Otherwise slightly it's going to change. But that's okay. If let's take 2 pi z. Okay. What is that I have got? That question in the telegram. It shows me 2 pi z. Okay, it shows me the 2 pi z. Done है जी. चलिए next question की तरफ. Okay, चलो जी. So next question. We have the next question coming up from control system. Coming up from the control system. There are two blocks given, having the gains GS and G1S. Having the gains GS and G1S. Okay, out of which the data is given to you. What is the data for GS? Okay, confirm me if you have seen this question. Okay, and what is the G1S? That is given by K S plus alpha upon S plus 4. Okay, K and alpha both positive, are both positive constant. Okay, what is the value of alpha? Okay, for the system to have, okay, For closed loop poles at -1 plus minus j root 3, okay, what is the value of alpha equal to? What is the value of alpha equal to? 0, 1, 2, 3. Come on. Done, hai ji? Chalo, so let's take up this answer. Okay, so first of all, what is the characteristic equation that you can frame here? Okay, 1 plus GSHS. Okay, so the overall forward path gain is a cascade of these two. So we'll multiply them. So I'm going to get K S plus alpha upon S square S plus 4 unity feedback hai, equal to 0. So solving it, I get S cube plus 4S square plus KS plus K alpha equal to 0. Now tell me, how do you approach this question? The poles are -1, random location is given, and that to cubic equation, -1 plus minus j root 3. Okay, some of you might think let's directly put -1 j plus minus j root 3, but then going for the cubic and square calculation will be a little bit lengthy. Okay, ab dekho, let us say this is some characteristic equation, f of s equal to 0. Okay, this is the original characteristic equation, f of s equal to 0, and it has the roots, okay, -1 plus minus j root 3. ठीक है, it has the roots -1 plus minus j root 3. ठीक है, right? Yes. So basically, okay, it's going to be a very simple argument now. If you try solving it, okay, yes, okay, but you don't know the third root, na Kasam Ravi. You can apply sum of roots, but where is the third root? It's a cubic equation. You can't only add these two roots. Otherwise, ये the aptitude का question हो जाएगा. It will not be a control system root. All right. So if you have to add, where is the third root? Okay, where is the third root? ठीक है. लेकिन third root निकाल सकते हैं हम. ठीक है, कर लेंगे, उससे भी कर लेंगे. It's a very logical thing. Okay, it's a very logical thing. Okay, so now if I just apply, let's say the third root. Okay, let's say the third root is suppose S3. Okay, is suppose S3. So we know -1 plus j root 3, -1 minus j root 3 plus the third root, which is S3, and that should be -4. This coefficient corresponds to -4. Okay, yes, Kasam Ravi, that's what I'm mentioning. The third root is not given, but you can immediately calculate. Okay, so then it becomes how much? J root 3 minus j root 3 cancelled. Okay, यहाँ पे आ रहा है -2 plus of S3 is -4. So the value of S3 will be -2. Okay, now the next thing that you can apply is the product of roots. Okay, product of roots से k alpha मिलेगा. Then how to come to the value of k, वो भी बताता हूँ. चलो, let's come to the value of k then. What is k? The coefficient of s. It is the pairwise product. Pairwise product means -1 plus j root 3, okay, into -2. Okay, next it should be -1 minus j root 3 into -2. Okay, and next it should be -1 plus j root 3. Okay, -1 plus j root 3, -1 minus j root 3. ठीक है, बताइए how much it's going to be. Now see, j root 3 minus j root 3 cancel होगा. So this is -1 into -2, 2. यहां से भी आएगा 2. And next, what is this? X plus jy, x minus jy will be x square plus y square. So that's going to be 1 plus 3. So k का value 8 आ गया. Yes, k का value 8 आ गया. ठीक है, what is the control system approach of this, वो भी मैं आपको बता दूंगा. Okay, but this is a logical approach now. Now, what is k alpha? It is the product of roots. Okay, -1 plus j root 3. Question को finish कर दिया हमने यहाँ पे. -1 minus j root 3 multiplied by -2. So this is, as I told you, 1 plus 3. Okay, and this is multiplied by -2. Correct? This is minus k alpha. The product is given by minus k alpha. Okay, like here the sum is given by minus b by a. The product is minus d by a. Okay, so here we have minus k alpha is equal to -8. Okay, k का value 8 था, तो -8 alpha is -8 and alpha is equal to the 1. Alpha का value हो गया 1. Done है. Alpha का value is equal to the done 1. Yeah, so that is the correct answer also. Alpha equal to 1. Answer number B. Now, if you're by chance solving control system way, okay, अब देखो, what is control system method? Okay, ये तो हो गया लॉजिक से. ठीक है, ये तो हो गया बेसिक एप्टीट्यूड अप्रोच. Okay, this is the basic aptitude approach. What is the control system approach? देखो, ध्यान देना. What you can do is, okay, if f of s equal to 0, okay, has the roots -1 plus minus j root 3, okay, when you right shift a function, okay, f of s minus 1 equal to 0, then the roots will also be right shifted by 1 and -1 plus 1 will be 0, so plus minus j root 3. So if you form a new characteristic equation, f of s minus 1 equal to 0, if you form a new characteristic equation given by f of s minus 1 equal to 0, that will have the roots plus minus j root 3. Now you know what to do. Pure imaginary. Okay, imaginary roots. Okay, imaginary roots, auxiliary equation, ROZ method, everything will come up here. Okay, so this you can continue and solve. This is Fs, make the S minus 1, replace everything by S minus 1. Okay, and that too is going to be cubic. Okay, so for cubic, okay, to be oscillatory, okay, for a cubic equation to give you oscillatory response, you can use the shortcut also. Inner product is equal to outer product. Okay, okay, and then by the auxiliary equation, you can satisfy the root, which is plus minus j root 3. So S square will be -3. You can try that. Can you try that? Can you try that? That is a control system method. Okay. They made it by this intent, but you have solved it by a very logical approach. Clear? Chalo, good. Good one, Kasam. Kasam Ravi. Next one, dear. Next one, dear. Okay, so both the approaches I have told to you. Now there is a question I have received. You have to confirm me the data. There is a question I have received. You have to just confirm me the data. Where is that? Yeah. The next question, dear, for all of you. The next question, dear, for all of you. It's a 2x1 mux based question. 2x1 mux based question. This is the output. Okay, connected in the feedback manner. And inverted output goes to the I1 input. Okay, and the select input is always fixed at 1. Tell me the select input is always fixed at 1. Okay, the mux delay. Okay, propagation delay for the mux is 10 nanoseconds. Propagation delay for the NOT gate is 0 nanoseconds. Confirm me the data, dear. Confirm me the data. Okay, confirm me the data. Come on, everybody. Yeah, you can do it with the root locus condition also, Devdutt. Okay, confirm me the data. Select line is always at 1. Okay, chalo, correct. So let's say this output is equal to Q. Okay, now because select line is 1, okay, what's going to be the next state of this? Because it's a sequential circuit, we can talk in terms of state. The next state, select line is always at 1. Okay, so this Q, yahan pe aa jayega Q bar. Okay, so it's going to be how much? It's going to be Q bar. It's going to be Q bar. Okay, it's going to be Q bar. Because select line 1 hai, to I1 select hoga. Okay, it's going to be Q bar. So Q plus equal to Q bar, what does it mean? It's the only inversion. It's only inversion. Now you can take any waveform at Q. Initially, suppose the output is 0. Okay, now this will happen. Okay, after how much time? The next state will be obtained after the delay of the mux, because the delay of the NOT gate is 0. Okay, that's ideally assumed, and this is 10 nanoseconds. So after every 10 nanoseconds, there will be inversion happening. Okay, so suppose this is t equal to 0, where the first inversion happened. Okay, the second inversion will happen at t equal to 10. Okay, 10 pe again toggle hoga, it becomes 0. Again after 10 nanoseconds, that means 20 pe it again toggles, and then etc, etc, etc. Okay, so now dear, what is the time period of the waveform then? Time period is 20 nanoseconds. Question mein kya pucha hai? What is the frequency? Okay, what is the frequency? So what is the time period you're getting? The time period of the Q waveform is 20 nanoseconds. Okay, so the frequency at the Q waveform is 1 upon 20 nanoseconds, 20 into 10 power minus 9. And options, I think you're telling in megahertz. Okay, so isko likh denge 10 power 9. Yeah. 10 power 3 into 10 power 6, divide by the 20. 1000 by 20 is 50, and 10 power 6 is mega. 50 megahertz is your answer. Okay, 50 megahertz. Check out, guys. Come on, 50 megahertz is your answer. Done it? Now, I have another question from, the circuits, from the sequential circuits. another question from the sequential circuit. Okay, but पूछा क्या गया exactly, that is not mentioned. There's a circuit diagram I have received by one of the student. I think Tejinder has shared to me. Okay, thanks for sharing, Tejinder. But I exactly don't know question में क्या पूछा गया है, तो आप लोग मुझे बताएंगे. There's another T flip flop here. This is Q and Q bar. Okay. Okay. And it's a synchronous circuit. Both are being working at the same clock. Both are working at the same clock. It's a synchronous circuit. Anji, confirm me if this is the data. Confirm me if this is the data. Confirm me if this is the data. Tell me. Okay, and if this is the data, check the circuit diagram if it is correct or not. Kasam Ravi says no. Tell me then what is the circuit diagram. Okay, and if this is not the data, let me know what is the data. Let me know what is the data. Come on. Surya also says. Okay, sir, for first T flip flop, there was OR gate. Okay, first flip flop, before flip flop, both flip flop have OR gate. So what is the input of the OR gate? Okay, OR gate for first T flip flop 2. Okay, OR gate for the first T flip flop 2. तो बताइए, if there is a OR gate for the first T flip flop 2, what is the input to it? Come on, what is the input to it? भाई input बताओगे ना, there should be two inputs to it. What is the input to the OR gate? Okay. Second flip flop output is connected to T. Inputs are Q1 or Q2 bar. Okay, Q1. Let's इसको मैं Q1 मान लेता हूँ. Okay. So guys, you are helping me with the question. What is that question? Is Q1 Q1 bar? ये हो गया Q2 Q2 bar. Okay. So what are the first input? Okay. Second flip flop input is Q2 Q1. अच्छा, ये तो पूरा ही डायग्राम गड़बड़ बता रहे हैं आप. First में Q1 and Q1 bar. Q1 and Q2 bar. Q2 bar तो आ गया है. Okay. Q2 bar तो आ गया है. There is also Q1. Is that what you are telling? There is also the Q1. There is also the Q1. Okay. Second T flip flop input is Q2 and Q1. Okay. चलो Q1 and Q2 bar आ गया. ये तो perfect है. That's what I have received from you. Okay. Q1 ना? Q1 and Q2 bar, not this one. Q1 and Q2 bar. ठीक है. Q1 and Q2 bar. Okay. So this I have taken as Q1. And this is Q2 bar. Okay, that is the input to the first T flip flop. Okay, that is the input to the first T flip flop. बताइए और क्या है यहाँ पे? और क्या है यहाँ पे? Okay, and the second one, okay, second one you are telling is Q1 Q2. Second वाला confirm करोगे Q1 Q2. Okay, second में what you are telling is Q1 Q2. Is that correct? Second वाला भी बताइए quickly. Okay, second वाला कुछ ऐसा है क्या? Tell me the confirmed data, dear. Tell me the confirmed data. Is this the second one? This is Q2 and this is Q1. Chalo. That's what I'm able to read from the comment box. Second one is Q1, Q2. Q1 and Q2, Q1 and Q2. Correct hai ji? Chalo, correct hai ji, correct hai ji. Q1 and Q2, second one you are telling. Okay. OR gate. चलो वो भी OR gate है. OR gate है. OR gate है. ठीक है. तो फिर आप AND क्यों बोल रहे हो? See the, let's talk in digital data. Let's talk in the digital language only. Okay. So ये भी OR gate है. Both are OR gate. Both are OR gate. But second में है Q1 or Q2. Clear? Now let us take this data. Now everyone says correct. Chalo, good. Memory based में यही होता है. Okay. At least we should, interact and come to the correct question. Okay. So chalo, whatever it is, let's keep solving now. Let's keep solving and let us start here. Q1, Q2, initially by default assuming to be 0, 0. Okay, initially by default let's assume to be 0, 0. अब देख लेना यहाँ पे dear. Okay, if initially all of them are 0. Okay, if initially these are 0. Q1, Q2, 0, 0. Okay, so what is here? 0, 0. So output is 0. Okay, what is here? 0, but Q2 bar will be 1. So this is 1. Now please see. Everybody please see. Okay, T1 is 1. So T input 1 toggle. T input 0 no toggle. So first one will toggle, second one will not toggle. First toggle, second do not toggle. अब इसको पहले remove करते हैं. Okay. First toggle, second do not toggle. Okay, now let me rewrite the input. Okay, 1 0, Q1 is 1, Q2 0 है तो complement will be 1, तो ये आ गया 1. Okay, this is 1 0, तो यहाँ पे आ गया 1. Both the T inputs are now 1. If both the T inputs are 1, both will toggle. If both the T inputs are 1, both will toggle. Okay, both will toggle, तो इसको कर दिया 0 1. Okay, now let me write down again here. This is 0. Now Q2 is 1, so its complement will be 0. So this T input is 0. Okay, this is 0 1, so T input 1. First one T input 0, second one T input 1. First wala not toggle, second wala toggle. First one will not toggle, second will toggle, and then we have the sequence completed. And then first wala not toggle, second will toggle, 0 0 repeats. So the transition is 0 0 1 0 0 1 back to 0 0. Okay, it should be mod 3. Come on, tell me, have you got this answer? Come on, tell me, have you got this answer? Come on, dear, tell me, have you got this answer? Come on, dear, have you got this answer? Keep telling me. Have you got this answer, dear? Come on. Yeah, anybody? Options for sequence tha? Okay, this is the sequence you have got. Great. Now let's go ahead to the next question. Let us go ahead to the next question. Mux wala kar liya, complex also done. What is the next question do I have here? Yes, dear. Keep sharing if you have any other question. चलो हेलो सर है कुछ क्वेश्चन आपके पास? अच्छा ठीक है, तो ले लेंगे आप? ठीक है, ऑन ऑन कीजिए. हाँ सर, ऑन कर लीजिए. गाइस, यस सर, संजय सर हैज वन क्वेश्चन ऑफ नेटवर्क सीक्वेंस. वैष्णवी, ये सीक्वेंस था ना? Okay, by the time I'll search if I have other questions in the Telegram. Guys, keep sharing in the Telegram. Okay, keep sharing in the Telegram. Okay, yeah, Tejendra, you have shared one network question right now, I know. Okay, I think I'll forward to that Sanjay sir को forward कर दूंगा.
There is one question on what maximum power transfer theorem, guys. Maximum
same
power
question.
transfer theorem, and what is the answer for this question, guys? Got the answer for that? What is the value of RL so that that battery will deliver the maximum power to RL? I think this is the question. Everyone, this is the question, guys. तो चलिए जरा मुझे कमेंट में बताइएगा. अब सॉल्व करते हैं. जरा बताइए व्हाट इज द आंसर फॉर दिस वन. व्हाट इज द आंसर फॉर दिस क्वेश्चन? Tell me, guys, what is the answer for this one? Okay. 1 minute. Yes, 1 EMFT 2.5 ohm. So number, yes, now, if you want the RL, then first of all, you have to convert it into what? Thevenin's equivalent. That is the VTH. And this is RL. RL is a variable load. Right? And then RL should be equal to what? RTH. Means we have to find the RTH. Now, when we want to find the RTH, there is a dependent source. Already we have solved one numerical on that. That is the VX 2 ohm, 2 and VX. Similar type of numerical we have solved. This time, this is the battery is connected RL. Now, if you want to find with dependent source, then what is the method here? First of all, remove this RL. Remove this RL. What is the answer? Everyone, please give me the answer and make it what? 0 volt. Make it what? If it is a voltage source, make it 0 just to find the Thevenin's resistance. because only the value of the RTH is required, and that's why directly we can find the Thevenin's resistance. You can connect a 1 volt battery here or 1 ampere current source. So just connect a 1 volt battery here. That will give the current I. Then what is the RTH? RTH will become 1 by I. Means you have to find the I only. Now guys, watch this. This is the Vx, this is the 2 ohm. This is the 2 ohm, that is the Vx. Means almost what? If suppose you are replacing the 3 ohm by Vx, if you are going to replace the 3 ohm by what? Vx. So these are the parallel paths. 2 ohm, 3 ohm, 2 and Vx. These are the parallel paths. Means we can say this I is divided into two equal parts. I by 2, I by 2. Is it visible, everyone? So I by 2, you can divide. This is the I by 2 and I by 2. Now, what we can do? Now we can write a KVL in this loop or what KVL in that loop. So here from that, you will get what? This is the already, because this is the same path, 3, 2, that is replaced by Vx, that is Vx, so I by 2. So directly write down the KVL here. Directly you can write the KVL in this loop. You can write KVL here. Now, according to KVL, this is -1 is equal to, directly we are writing the KVL. So this is the -1 plus 3 into I by 2 plus 2 into I by 2, directly you can write. That is equal to 0. It will become what? 5 by 2 into I is equal to 1. Now, that is equal to 1. So what is the 1 by I? Because RTH is required. So I is no doubt 2 by 5. I is what? 2 by 5 ampere. But what is the 1 by I? 1 by I will become 5 by 2 ampere ohm. And that is nothing but 2.5 ohm. 2.5 ohm. Okay. This is the value of RTH. Maximum power was required or only the RTH, guys? Only the RTH. Sir, can we use the Thevenin for dependent source? Yes, we can apply the Thevenin. So what is required in the question? Confirm कर दीजिएगा. क्या पूछा गया था आपसे? Only RT, only the value of RL for maximum power. Only RL, then the answer is what? 2.5 ohm. Answer is what? 2.5 ohm only. Okay. So if you have the more question, then please send me. So only RL. So this is the answer, 2.5 ohm. Similar type of questions we have solved. That was given here, 2 ohm Vx 2 ohm. We have to find the I, then same path, right? And that's why the current will divided into two equal parts, I by 2 and I by 2. And we have to find the I in that case. But here simply we have to apply what? VTH and RTH. अगर आपने practice किए तो आपने बना लिया होगा, ये question easy है. Okay. एनालॉग के भी क्वेश्चंस हो गए. कुछ और क्वेश्चंस आप सेंड करेंगे तो और मैं बनाता हूं, राइट? और राकेश सर अभी और वेट कीजिए, जस्ट राकेश सर कुछ क्वेश्चंस पे काम कर रहे हैं, वो क्वेश्चंस लेकर आएंगे और भी हम लोग क्वेश्चन सॉल्व करेंगे. ओके. और अभी जस्ट आफ्टर द गेट एग्जाम मींस हो गया अब आप लोगों का गेट, अब इलेक्ट्रिकल भी हो जाएगा, इलेक्ट्रिकल की भी एनालिसिस होगी, राइट? देन गाइस रिमेंबर, पोस्ट गेट सेशंस हैं, आपके कितने मार्क्स आ रहे हैं, क्या आपकी अपॉर्चुनिटीज बनेगी, कहाँ आपको एमटेक करना है या कौन कौन से पीएसयूज के बारे में, हर डिटेल इस चैनल पे होगी. तो आपने सब्सक्राइब अगर चैनल नहीं किया है तो सब्सक्राइब कर लीजिए चैनल को, राइट? और क्वेश्चंस अगर आपके पास हैं तो क्वेश्चंस थोड़ा मुझे फॉरवर्ड कर दीजिए ताकि मैं आप लोगों को क्वेश्चंस नेटवर्क के या एनालॉग या फिर आपके ईडीसी के क्वेश्चंस हैं या जो भी सब्जेक्ट में आप लोगों के पास क्वेश्चंस है उसे फॉरवर्ड कर दीजिएगा. यस प्लीज.
Yes, sir.
ओके सर, क्वेश्चंस
Yeah,
हैं?
I have 2-3 more questions. Just 1 second.
ओके सर. राकेश सर आ गए, राकेश सर अब सॉल्व करेंगे क्वेश्चंस.
Yeah, I think sir, many of the questions already done. डिजिटल के भी
Okay.
4-5 कर चुके हैं, सिग्नल्स के भी 3-4 हो चुके हैं, तो क्वेश्चंस काफी हो चुके हैं. बट या आई हैव गॉट 2-3 मोर क्वेश्चंस करते हैं.
ठीक है सर.
Okay. So guys, okay, 1 question from signals and 2 from aptitude. That is what I have got. Aptitude के I think 2 कर चुके थे, 2 more I have got. Okay, so there are 2 sheets A and B. A and B. Okay. they are of dimension 24 cross 16. 24 cross 16. Okay. 24 cross 16. Okay, and now there are two operations given. Okay, there are two same sheets. मतलब दोनों का dimension same है. Okay. So there are the operations given. There is one operation given as F0. Okay, there is a folding operation given F01. F01. Okay. Folding along the initial long edge. Okay, and there is another operation F02 or जो written है यहाँ पे. Okay, there is the folding of the sheet. There is a folding of the sheet along the initial short edge. Along the initial short edge. Okay, now next बोला है sheet A is folded. Okay, A is folded. Okay, twice using FO1. Data confirm कर देना. B is folded. B is folded twice using FO2. Okay. Okay. Find the ratio of perimeters of final shapes. Chalo. Tell me whether you've got it or not. And guys, today we have received only one EMT question till now from the student side. That is on the transmission line. Simple tha. Minimum characteristic impedance, minimum input impedance pe. If you have any EMT questions, I'm eager to know that. Okay, I'm eager to know that. Control ke to still we have got 2, 3. Digital we got 4, 5. Signals ke bhi 4, 5 question aa gaye the, but we have got very less from EMT questions today. So if you have, please share me. Okay, I'm regularly checking the Telegram also. So dekho, FO1 and FO2. Okay, the size is 24 cross 16. Okay, the size is 24 cross 16. Okay, 24 by 16. Okay, 24 by 16. अब देखो, बहुत simple सा approach है ये. You know, if you have seen yesterday's CS paper also, there are questions on paper folding, similar geometrical questions on paper folding. Now, FO1, okay. इस पे मैं 2 times करूंगा. So what is the FO1? Folding along the initial long edge. Initial long edge. And what is the initial long edge? Okay, initial long edge 24 है. इसके along fold करेंगे. Okay, the sheet, what is going to be half? The 16 will become half. Okay, that will become 8. Okay, but again folding, like here, initial long edge is horizontal, the folding will be along horizontal only. Every time along the initial long edge. तो जब दो बारी fold करोगे, what are you going to get, you know? When you do it twice, na, what are you going to get? This is what you're going to get. Okay, 16 divide by 2, further divide by 2. Okay, ये divide by 2 दो बार होगा. 16 divide by 2, proper bracket लग के रखते हैं. Further divide by 2, so that's going to be 4. Okay, that's going to be 4. Clear? ठीक है. Now, here I am going to apply the operation FO2 and that is twice. And what is FO2? Initially short edge. Initial short edge is vertical. Okay, so when you fold it along this 24 will be halved. Again folding 24 will be further halved. Okay, 24 will be further halved there, but 16 will not be affected. This 16 remains to be 16, but this is going to be 24 divided by 2, that is 12. Further divide by 2, that's going to be 6. That's going to be 6. Okay, so what is the required ratio? Okay, eventually both are representing rectangular shapes. Okay, twice into length plus breadth, 24 plus 4, divided by twice of 16 plus 6. Okay, so that's 28 upon 22. 2 से cancel करेंगे, तो it's 14 by 11. It's 14 by 11. Done है जी, tell me. It is 14 by 11 is the very correct answer. ठीक है, चलो. Done है. 14 by 11. Yes, Tejendra, correct. One question on EMT based on lambda by 8 wave. If you have the question, if you remember, Vikram, by chance, the exact question, please let me know. If you by chance remember that exact question. Chalo. So guys, next question coming up. One more from aptitude and then एक signals के question पे जाएंगे. The question is, okay, पहले बात करेंगे 5 years ago, okay, the ratio of Aman, very basic question on, you know, ages. the ratio of Aman's age to the father age. Aman's age to his father's age. Aman's age to his father age is 1:4. Okay. And 5 years later, okay, the ratio will be, okay, the Aman's age, okay, is to father's age. That's going to be 2:5. Just rectify the data one. Okay. Okay. What is the father's age? When Aman was born? Okay. 35, 30, 28, and 32. Come on. Chalo, tell me. So dear, okay, from here, from this data itself, 5 years ago, okay, 5 years ago, Aman age is A-5 and father's age will be F-5 and that is given to you as the ratio. Okay, 1:4. Okay, so you have 4A minus of 20 will be F-5. So there is a clear relation and that is 4A minus 15. Okay. F should be equal to 4A minus of 15. 4 times the Aman's age minus 15. Okay. Now, from here, okay, from here, okay, from here, okay, let's say A and F are their current ages. Okay. From the second statement, you have the data 5 years later. That is A plus 5. When it is divided by F plus 5, that is 2/5. Okay. So, यहाँ से आ जाएगा 5A plus of 25 is 2F. Okay, plus of 10. Okay, so let's figure out their ages. 5A plus 25 is equal to 2F. Okay, and F is 4A minus 15. 4A minus 15. ठीक है, present से हम देखेंगे. Okay, so 5A plus 25 is equal to 8A minus 30. So the value of 3A, is 55. Okay, ये इंटीग्रल नंबर में नहीं आ रहा है क्या? लेट मी चेक द डेटा वंस. 5 years ago 1:4, तो 4A minus 20 is F-5, तो F is equal to 4A minus of 15. ये करेक्ट हो गया. 5 years later it is 2:5. A plus 5 upon F plus 5. A and 5, I assume the current age is 5A plus 25 is 2F plus of 10. Okay, अच्छा ये plus 10 यहाँ पे मिस हो गया ना. Okay, 2F, F is 4A minus 15 and यहाँ पे further 10 लिख दिया. Okay, now it should be okay. So what we have 3A. Okay, 3A is equal to ये हो गया 45 and A, the current age of Aman is 15. Okay, so what will be F? What will be F? The current age will be 4 into 15 and 45. Now देखो, I know their current ages. ठीक है. Aman is 15, father is 45. So when Aman was born, Aman's age would be 0. The father's age would be 30, na? It will be 30. Okay, it will be 30. Correct answer is B. Okay, when Aman was born. Okay, so Aman was born, okay, 15 years ago. Aman was born 15 years ago because the present age of Aman is A. Okay, so 15 years ago, the father's age, okay, जो कि current में 45 है, तो 15 years ago it would be 30. Right है जी? 30. ठीक है, 30 done है. चलो. Done. So now let me take up the next question. I have received one more. Chalo. Let us see. Just 1 second. Hello. अच्छा ठीक है. और साकेत सर के पास? ठीक है. एक ही है आपके पास? ठीक है. मैं करता हूँ. बस मेरा लास्ट है, फिर मैं आपको देता हूँ. Transmission line short circuited load. Okay, tell me the exact question, Lakshmi, or if you have, please share it in the Telegram. It will be a big help. I want to solve as many questions as possible. Okay, let us solve as many questions as possible. Chalo. Chalo. Yeah, so one good question from signal and system. Okay, then Sanjay Rathi sir has one analog question also. Okay, so the relation between, the relation between an n-length sequence, there is an n-length sequence xn. There is an n-length sequence xn, and you have a corresponding n-length DFT xk, n-length DFT xk, discrete Fourier transform xk, defined as xk, xk as f of xn, the Fourier transform of xn, the discrete Fourier transform of xn. Now you are given yn is equal to f 1, 2, 3, 4, f of xn. Okay. ठीक है, चलो. If that is the question, question में क्या है? Okay, if the xn is also given to you, what is the sequence xn is 1, 2, 1, 3. Okay, what should be the value for? Okay, what should be the value for y0? Okay, what should be the value for y0? What should be the value for y0? Tell me. ठीक है, 4 लेंथ. हाँ, इट्स अल्टीमेटली 4 लेंथ. चलो 7 या 16. करेक्ट, 16. देखो एकदम लॉजिकल रखना. ओके, नो नीड टू हैव अ लॉट ऑफ बर्डन ऑफ द फॉर्मूलास. ओके, इट्स अ वेरी लॉजिकल अप्रोच. ओके, 4 टाइम्स Fourier transform you are calculating. ओके, इट्स अ duality. You can solve it by duality. देखो, xn has the DFT xk. Okay, that is the first DFT. I need to do 4 times DFT. I'll tell you the logic. Now, if you apply duality, what is the duality in DFT? Okay, that capital Xn, you convert this to time function, has the DFT n small x minus k. Okay, small x minus k. So this is the second DFT. Okay, DFT of DFT I have taken. Yeah, DFT I have taken the DFT of this. Okay, I've taken the DFT of that. Okay. Capital Y0 बोला है ना, चलो ठीक है. The capital Y0 means yeah, actually we'll see what is, whether it is capital or वो सब देख लेंगे यहाँ पे. ठीक है. This is the second operation given. ठीक है. अब यहाँ पे देखना, to explain you, let me assume that this is x1n. Time function कर दिया ना, I've converted it to a time function. What is its DFT? Suppose its DFT is x1k. Okay, now once again duality, dear. Now if you apply once again duality, okay, x1n will have the DFT, that is n small x1 minus k. So this is the third DFT I have taken. Okay, now let us say this capital x1n, is some signal x2n, okay, in the time, and this is its corresponding DFT, capital X2k. ध्यान देना ना, capital X2k. Now the next thing is, now fourth DFT. Now what is the fourth DFT? Okay, what is the fourth DFT? It's going to be x2n. I replace k by n. Okay, and then this is going to be given by n x2 minus k, n x2 minus k. Okay, this is going to be your fourth result. Okay, this is the fourth DFT. Okay, ठीक है. Now what is the yn? It is the DFT. F means DFT of 3 times DFT. Okay, मतलब इसको मैं ऐसे बोल सकता हूं. This is what first Fourier transform is xk. Just understand with me. First Fourier transform is xk. Then what is my second Fourier transform? My second Fourier transform is x1. My third is x2. Okay, my second Fourier transform Okay, this one is x1. My third Fourier transform is x2. Okay, and final वाले को y बोल देंगे. Okay, final वाले को y बोल देंगे. ठीक है, final वाले को y बोल देंगे. Okay, so let's say this is what is your yk. Okay, let's say this is what is your yk. Okay, and then let me call this as the yn. Okay, let me call this as the yn. Okay, इसको yk बोल देते. So what is the yk, dear? What is the yk? Okay, what's going to be the yk after the fourth DFT? Correct, Varun. Okay, so what's going to be the yk? Yk is n x2 minus k. It is n x2 minus k. Okay, what is the value of x2? Place करते जाइए ना. What is the value of x2 minus k? It is x2n is x1n, so that is basically capital X1 minus n. Further, let me place the value. What is x1? Further, let me place the value. What is x1? It is nx minus k. Okay, so this becomes n. Okay, x of minus n. Okay, by x1 minus n चाहिए ना, तो x1 minus n, x of minus n. Okay, so that is why it becomes a time function. Ultimately, that's what is yn for me. Okay, capital small जो भी given है. So basically, what yn is n square x of minus n. So what's going to be the y0? That's going to be 4 square, length is 4 into x of minus 0. Okay, and the signal x0, the first sample of the signal is given to you as 1. Okay, the first sample is given to you as 1. कहाँ चला गया? Okay, x minus 0 is simply x0 only, and that is given to you as 1. So answer is 16. Answer is 16. ठीक है? Okay. If see now this is memory based. Okay, this is memory based. अब देखो, if the what you are telling is, ध्यान रखना. Okay, in the question it is given. Where is the question? In the question it is given small yn. What is the value of y0 या capital Y0? Capital Y पूछा है तो एक और DFT निकालना पड़ेगा. अगर capital Y पूछा है तो एक और DFT आएगा, dear. Okay. If there is capital Y, there will be one more DFT. नहीं. If there is the capital Y0, I have taken the small y0. Let me check what is the question I have. Okay, if they ask capital Y0, okay. इसको y के बोला because after fourth DFT I have the time function only, na DFT of DFT. Small y होगा, correct Varun? Okay, so see if they ask small y, that is my answer. If they ask capital Y, okay, मैंने आपको approach बता दिया. Okay. Some of you say capital Y, some of you say small y. Okay. Okay, 16 can be the answer if the question is, okay, y0. They've called it as yn. Okay, DFT of DFT. Okay, DFT of DFT. Okay, DFT frequency function. Another DFT I've taken. Okay, so accordingly. ठीक है, हाँ, अगर capital Y पे जाना है तो one more DFT has to be considered. Okay, because yn itself is 4 DFT. DFT of DFT. अगर another DFT. Okay, अगर another DFT बोला जाए, ठीक है, if there is another DFT, then what are you going to do? Okay, if this is the fourth one, okay, if this is the fourth one, देखो, then what's going to be the fifth one? What's going to be the fifth one? यहाँ पे आप देखेंगे, okay, so I've called it as, this fourth DFT itself, they have given it as y. Okay, इसको उन्हें yn बोला था. This they have called it as yn. Okay, we can convert to k to n. Okay, तो अगर कैपिटल में लेके जाना है तो one more DFT you have to consider, and one more DFT means, okay, so one more n multiplication will come. N is 4. Okay, so वो 64 की तरफ आपको लेके जाएगा. Okay, you have to check that. So whether it is small or big, that you have to check, but not necessarily 64. Then you have to calculate. वहाँ पे एक और catch आएगा. What is the sum of this signal? Okay, 7. Okay, 4 into 4. Maybe one more 4. 4 into 4, 16. 16 into 7 आ जाएगा then. Okay, into 7 will come. So that you have to check, guys. कैपिटल में क्या होगा, चलो वो भी बता देते हैं. ठीक है, अब अगर इसका एक और DFT निकालना है, ओके, अगर इसका एक और DFT निकालना है, ओके, मैं कहां पे स्टॉप हुआ था? लेट मी बिगिन फ्रॉम देयर. ओके, आई हैव द x2n. लेट मी टेक द अनदर स्लाइड. I have the x2n and that has the DFT. What is that DFT? It is given by nx2 minus k. That is given by nx2 minus k. That was my fourth calculation and I have called this as yn. Okay. If I want to again calculate, okay, the DFT of this one. Okay, what's going to be the DFT of this one? Okay, what's going to be the DFT of this one? Okay, so ये यहाँ पे आ जाएगा, ये यहाँ पे आ जाएगा. I've called it as yn. ये letters बड़े confuse कर देंगे. This is going to be x2 of minus k further multiplied by n. Okay, further multiplied by n if you take another DFT. If you take another DFT. Okay, now that's going to be n. If I go for the fifth time, okay, that's going to be how much? Okay, n x2 minus k. Okay, what is the value of x2, dear? What is the value of capital X2? Okay. What is the value of capital X2n? Okay, that is n x1 minus k. That is n x1 minus k. Okay, so this is n square. Now, what is x1 minus k? What is that x1? Just a second. That is n x1 minus k. What is the small x1? Okay, that small x1n is x capital Xn. Okay, so that's going to be capital X minus k. K के फॉर्म में रखना है कैपिटल X माइनस के. तो अगर Y के अगर फिफ्थ DFT पे जाना है तो दैट इज n स्क्वायर, n क्यूब नहीं आएगा, दैट इज x ऑफ माइनस के. ओके, सो y ऑफ 0 ओके विल बी n स्क्वायर x0. नाउ व्हाट इज x0, डियर? नाउ व्हाट इज x0? व्हाट इज x0? 4 स्क्वायर. ओके, सिंपल एडिशन तो करेंगे बट कितने टाइम्स DFT निकालना है वो देखना पड़ेगा ना. ठीक है, 10 points. Now, what is capital X0? The capital X0 is given by sum of the samples, that is 1 plus 2 plus 1 plus 3. That's what I was telling you. तब 7 multiply होगा. 16 into 7, 112. 112. ठीक है. अब देखो, depend करता है what is the question. Depend करता है what is the question. Okay, so that you have to see. If the question is Y0, then the answer is 16. If the question is capital Y0, then the answer would be 112. Okay, then the answer would be 112. That is what. मैंने आपको दोनों चीज बता दी है. Okay. Capital था तो 112. No problem. Because some of you are telling small, some of you are telling capital, many of you are telling capital. Capital Y0, 112, small y0, 16. Done? ठीक है. ठीक है, done? No issues now? No issues now? ठीक है. चलो. So dear, now Sanjay Rathi sir is ready with yet another question. Sanjay Rathi sir is ready with yet another unlock question. Come on, Sanjay sir, if you are live, you can join with on the Zoom.
हाँ सर.
Yeah.
तो देयर वन क्वेश्चन सर, बस उसके बाद आप ले लीजिएगा. दैट इज वन क्वेश्चन फ्रॉम व्हाट एनालॉग गाइस. प्लीज एवरीवन वेरीफाई इट. दैट इज व्हाट आई एम ऑडिबल. Then this is a question. This is the MOSFET CL C1, that two capacitors are given. And what is asked here? Find the input impedance. Find the input impedance. That is the correct one. This was the question, guys. Everyone. Now, if this is the question, means in a low frequency model, that is the channel length modulation is, we have to neglect the channel length modulation, all the internal parasitic capacitance we have to neglect. Only we have to consider the external capacitor C1 and CL, guys. Right? So what is the impedance? Always remember, in network we have learned, if you want to find the impedance, means this is the voltage divided by I, that is given by Zi, V by I. That is the impedance. Input impedance, V by I, we have to find. Now, it is the MOSFET, we have to connect what small signal model. But remember, channel length modulation is negligible. So what is the small signal model here? We are having the small signal model. This is the GM VGS, right? And this is RD. RD. That is the source terminal. This is the gate terminal. This is the source terminal. This is VGS. Okay. And that is the drain. And this is the source. That is a small signal model. But if the channel length modulation is negligible, means what? This RD tends to what? Infinite. Means it will act as open circuit. Now this is the S. From this point to this point, this voltage is what? VGS. We have to apply the small signal model. तो आपका आंसर क्या है जरा बताइएगा. There was a, this is the MCQ actually. This is the MCQ. There was a 4 options, A, B, C, and what? D. I'm not having the answer, but I'm going to solve it. Okay. Now, A, B, C, D, this is the MCQ. Means there is a negative marking. Then how we can solve it? Very simple. You have to apply the small signal model. With the help of a small signal model, we can solve. Then This is the small signal model. Be careful. GM VGS. Right first. Second, what is the RD infinite? Remove. Now, watch this. The voltage from gate to source, it is VGS. This is the gate, this is the source. And that is the drain. Drain is connected to ground. So this is the drain. Drain is connected to ground here. From source to ground, CL is connected. So from source to ground, you can connect a CL. Right? Now remember, you can replace the CL 1 by SCL, or finally we will convert the S is equal to what? J omega, then 1 by SCL here. Now this is the source terminal. Now watch this. From gate terminal, VI is connected. This is the source. Now this is the gate. This is VGS. Remember, this is the VGS. Always remember, this is VI. With ground, we have connected the VI. This is the ground. Now, there is another thing. From gate to source, one capacitor is connected, C1 here. From gate to source, we have one capacitor, that is the C1. This is the C1, is connected. So we can replace 1 by SC1. Okay. Now, this is the current I. This is the current I enter through this terminal. Now, what is the impedance of that? Infinite. That's why this current will pass through the C1. So this is this path will act as open circuit. So same I will flow through 1 by SC1. At this junction, what is the current? GMVGS, and this is I. So what is the current here? GMVGS plus what I? Now, you can write a KVL from this point to this point. From this point to this point. You can write a KVL, guys. But remember, we have to replace the VGS because we want VI by I. Which one is the villain? VGS is the villain. To remove the VGS, you have to write the KVL at this point in this loop. When I am writing the KVL, you will get VGS is equal to this is in parallel, I into what? 1 by SC. 1 by SC1. Right? Now, you can write a KVL in this loop. So, you can write VI is equal to I into 1 by SC 1 plus GM VGS. GM VGS is replaced by I into 1 by SC1 plus I, and that is multiplied with what? 1 by SCL. 1 by SCL. Now you can take I common. So this will become VI by I. So when I am getting the VI by I, what is the VI by I? 1 by SC1. 1 by SC1 plus GM by SC1, right? And plus 1 by SCL. 1 by SCL plus GM SC1 SCL. Yes, so that is the multiplied, and I we have taken. Now this is the answer, but it is given in a complex. That is the ZI, input impedance. Now you can replace the S by what? J omega. Then it will become ZI is equal to 1 by J omega C1, 1 by J omega L CL, SCL, J omega CL, right? And now plus GM, this will become J square C1 CL, right? And omega square. Now, what is this? Minus. That's why you will get the minus GM. I think that is the answer. Omega square C1 CL plus 1 by J omega C1 plus 1 by J omega CL. And that is the answer for this question, guys. Input impedance. Okay. This is the question from analog. लेंथी क्वेश्चन बट इजी था, इसको आप सॉल्व कर सकते थे। इनपुट इम्पीडेंस के क्वेश्चंस मैंने काफी क्लास में आप लोगों को बताया हैं, जब भी आपको इनपुट इम्पीडेंस सॉल्व करना है। यस, यू आर गेटिंग द सेम आंसर गाइस, टेल मी, यू आर गेटिंग द सेम आंसर फर्स्ट शिफ्ट ईसी का? यस सर, आई हैव बेसिक डाउट अबाउट द कैपेसिटर, कैन आई आस्क देव? हाँ पूछ सकते हो अगर ये क्वेश्चन पेपर से रिलेटेड है, अदरवाइज और अभी सेशंस होंगे। तो ये था, मतलब इसको हमको सॉल्व करना था बाय यूजिंग द स्मॉल सिग्नल मॉडल, और नेटवर्क का कॉन्सेप्ट यूज करना था वी बाई आई का। अब राकेश सर ज्वाइन करेंगे, ये दैट इज द क्वेश्चंस। और भी अगर आपके पास क्वेश्चंस है तो ऑन टेलीग्राम चैनल, और बाकी आपको जो भी मीन्स है आप उसमें सेंड कीजिए, व्हाट्सएप ग्रुप है, हमारा ग्रुप है, उसमें आप सेंड कर दीजिए, तो क्वेश्चन हम लोग सॉल्व करके आपको आंसर प्रोवाइड कर देंगे। आई थिंक नाउ राकेश सर विल ज्वाइन, ओके। और sir, couldn't derive it in time, sir, means what? You want the answer in time domain. This is in frequency domain, guys. So impedance is required. Now, what is the impedance because of the capacitor then? What is the impedance because of the capacitor? That is given. Now, what is question asked actually? Answer is given in this form. I think that is the answer. Minus EM and so on, 1 by and 1 by j omega CL. That is the answer actually. Okay. विक्रम, क्या चाहिए, आप क्या बोल रहे हैं? एक बात बताओ, ये आंसर आया था, कितने लोगों का सेम आंसर आया है? इट इज अ एमसीक्यू, इट इज व्हाट एमसीक्यू, मतलब मॉसफेट। आई थिंक मैंने आपको बहुत सारे मॉसफेट के सेशन लिए थे, देन मैंने बताया था आपको ज्यादातर क्वेश्चंस अब मॉसफेट बेस्ड आएंगे, तो आई थिंक कुछ और भी क्वेश्चंस आए हैं मॉसफेट पर बेस्ड। अगर आपके पास वो क्वेश्चंस है तो वो मुझे सेंड कर दीजिएगा, ओके। अच्छा, उस टाइम नहीं कर पाए आप क्वेश्चन? ओ, अब आप, अच्छी बात है। तो चलिए, कॉन्सेप्ट पढ़ोगे कि जो इंसुलेटर है बीच में कैसे काम करता है, कैपेसिटर के अंदर से करंट कैसे फ्लो करता है, मतलब इस पे अब जब भी कोई सेशन स्टार्ट करेंगे ना, दैट इज विद व्हाट वेरी बेसिक्स। बहुत अच्छा क्वेश्चन है कि जब प्लेट के बीच में कुछ है ही नहीं तो करंट कैसे फ्लो कर रहा है ना? चलो, अभी तो ये प्लेटफॉर्म नहीं है कि इसको डिस्कस किया जाएगा, लेकिन ये अच्छा क्वेश्चन है कि चलो बेसिक्स, बेसिक्स पर भी क्लासेस होंगी जहां से स्टार्ट करेंगे कि कैसे आपका करंट वगैरह फ्लो करता है। ओके विक्रम, क्वेश्चन गलत नहीं है, लेकिन ये अभी वो प्लेटफॉर्म नहीं है। आपके पास और कोई क्वेश्चन है आज जो आया है? एनी अदर क्वेश्चन? चलिए एक बार मैं भी देख लेता हूँ आपके और भी कोई क्वेश्चंस हैं क्या। वन मिनट। नेटवर्क के क्वेश्चन आपने कहा है इजी है। देखो, अगर एनालॉग के क्वेश्चंस के अगर आप कॉन्सेप्ट्स लगा रहे हैं तो थोड़ा तो टाइम लगेगा, लेकिन उतना ऐसा भी नहीं बोल सकते कि आप बहुत ज्यादा, या फिर कैलकुलेशन पार्ट थोड़ा सा लंबा है, कैलकुलेशन का पार्ट थोड़ा लंबा हो रहा है, ये तो है। यस प्लीज। अच्छा, आप मतलब वहां एक्सप्रेशन नहीं निकाल पाए। एंड मॉस्फेट एक और भी, जैसे अब कंडीशन फॉर ऑसिलेशन भी आया था, वैसे ही क्वेश्चन आया, व्हाट इज द कंडीशन फॉर द ऑसिलेशंस, राइट? उसको भी आपको सॉल्व करना था वहां। अगर पहले से आपने सॉल्व किया हुआ है तो इजीली आप सॉल्व कर सकते हैं, अदरवाइज वी हैव टू सॉल्व। हम्म।
Yes, sir.
ओके सर।
Sir, is it done? Yeah, left.
डन सर, डन।
Okay, sir. So just I have maybe one or two questions, and then we are joining again. We'll talk about the cutoffs and all.
ओके सर।
Chalo, dear. Okay. Okay. So I was asking you for the electromagnetics question. One I have received here. Okay. The question is, which of the following? Okay. Which of the following are electrostatics fields? What is happening? Tell me, dear, have you seen this question? Okay, have you seen this question? Come on, everybody, let me know. Okay, so now electrostatic field, static bola hai clearly, and electrostatic fields are conservative in nature. Okay, electrostatic fields are what? They are conservative in nature. The electrostatic fields are conservative in nature. Okay, del cross E, okay, is equivalent to 0 in the static. Okay, time varying fields are not conservative, but electrostatic fields are conservative. So what is this question? It is a basic curl calculation. Okay, it boils down to a basic curl calculation. So quickly kar lenge, dear. Okay, quickly kar lenge. So if I have to calculate del cross F1, okay, the first vector F1, okay. So basic determinant calculation. Let me write down the partial derivative terms. Del by del x, del by del by del by del z, and then you have this term ay, and then you have the term ax. Okay, and this is clearly because it's only in the two variables, so of course it will only involve the az. Del by del x of ax would be a, minus del by of ay is again a, so this is equal to 0. Okay, the first of the field is definitely electrostatic. Okay, second वाला अगर यहीं पे कर दें, देखो ध्यान रखना, second वाले में only difference is this will be minus ax if you have to solve with respect to f2. Okay, so del cross f2, dear, okay, not repeating the entire calculation, del cross f2, okay, is going to be how much? Del by y of ay, which is again a, minus del by del x of minus ax. Okay, so this is going to become minus minus plus 2aaz, ultimately not equal to 0. Curl of a not equal to 0 means the second field cannot be an electrostatic field. Okay. Now, Vikram, how both are electrostatic fields? Clearly not. Clearly, the second one is not. Have a look into this calculation. The second one is not. Only the first one is electrostatic. So I don't have the options, but maybe there will be 4 options. Okay, only F1, only F2, both F1, F2, yeah, neither F1 nor F2, something like that. Okay, the question is going to be there. Yes, Vikram, just check it out once. Just check it out once. Yes, so I have MN sir again now joining with me. Yes, Jishnu, correct, only F1. I request Sanjay Rathi sir also to join live now. Okay, we have done lots of questions, guys, and you can also take a break now. Okay, maybe we receive more questions, but once we receive the complete paper, anyways, we are going to give you the full 65 question authentic solution.
Yeah, these are all just memory based. We don't know how the data is correct or not, to what extent the data is correct.
Yeah.
Hope everything is correct because the students generally share and we cross check also before delivering this question. But anyhow, once the this final key, I mean we'll get the paper.
Response key on 16.
Response key, yeah.
Around
When
16.
we get the response key,
I think that
we'll give you the complete solution, detailed solution also in a shortest
where is that?
time.
Yeah, we have that data also about the response key. The date sheet was attached here. I'll just show it to the students once. Just a second. Yeah, here it is. These are the important dates now. Okay. So 16th of February, we are expecting the response key. Okay, and if ISC has mentioned it's going to be 16th, so it's 16 maximum 17th. Sometimes it may be one day preponed also. The plus minus one you can always take. Okay, final official answer key will be available by 21st of February. Okay, but don't worry, as soon as we get the response key means with questions, students get it. So we get the official question paper. We will release from BYJU'S side the answer key within the same day only.
Then you can check with the...
Correct. And by that time only, guys, now very important announcement here with respect to the 16th Feb is the rank predictor. Okay, the BYJU'S exam prep rank predictor is going to be live once your response key is out. So once you see what response you have marked, okay, you can directly go to the BYJU'S exam prep app. Okay, download it. If you don't have it, you can directly download from Google Play Store, or you can go to the YT description, YouTube description of the same video. You will get a link to download, and there you will have the rank predictor, which will be live from 16th February. I mean, just as the answer response key for the students are released. You can use the rank predictor.
You can estimate your rank, how much is going to be your roughly, exact rank nobody can predict, but roughly you can get the rank what you are going to get based on the answers. And
yeah, maybe for the initial first day it might not be that accurate because for more accuracy we need more sample space, more data. Okay, but yeah, maybe next 2-3 days your data will be near about what you can expect in the GATE rank. So you will come to know what is your exact marks you're scoring. And out of that exact marks, what is your rank out of all the thousands of students for electronics who have participated in the examination? So do not miss to check your rank in the rank predictor.
Keep updating your rank also in that predictor.
Okay. So 21st official answer key will be there by IIT, and then now challenges. Okay. if there are some questions to be challenged, that you can challenge from 22nd to 25th of February. We will also guide you. Okay, let us
Yeah,
wait
on
for
16th only, we will give you the solutions. And 21st, you can see the discrepancy.
Yeah.
Then we'll have a session also whether it can be challenged or not. That's
Correct.
when
Like every other year, we will tell you ki whether you can challenge this
Challenge it
question
or
or
not.
not, and we will also support you in how to challenge, how to write down that particular challenge. Okay, and then you know that. What about the final answer key after challenge? The final answer key, they don't give any date, but let me tell you. Okay, just one day before the result, the final answer keys are there. Okay, approximately 1 or 2 days before the result, final answer key आएगा. ये मान लेना जब final answer key आएगा after the challenge, the next day result is going to be there. It's an indication of that also.
Correct.
Okay, so rank predictor you have to use on the BYJU'S exam prep app, as I mentioned you. And now, guys, gate analysis is done. We are going to come live at 5:30 p.m. for the electrical analysis also. Okay, so after that electrical, the gate festival is now over for 2024, but ESE 2024 prelims just in another 1 week. Okay, so sir,
ESE
18th of-
exam, we always say that, it's like continuation of your journey from gate to ESE. Syllabus is almost same. So pattern is also almost same for the prelims. Only the syllabus extra part is non-tech part. So that is also going to be live on 18th Feb for you.
Yes. Okay, so 18 Feb, our entire team, we will do the paper 1 and paper 2 both analysis. Paper 1 is of course common for all branches, so that will be a common analysis. But paper 2, we will have branch-wise analysis for EC, for EE, for mechanical and for civil. Okay, so entire team, okay, combining all branches will be there, and we'll have the analysis on 18 February. That is the next Sunday, okay, in the evening slots, because the paper 2 gets over in the evening. So after that, after 5 p.m. we will have it.
Rakesh, some students are curious to know the cutoff and what is the good attempt. Some
Correct.
students
Coming to that only
asking
eventually.
for 52 is a good attempt or not. Let's conclude, guys.
Yeah.
Let's take Sanjay sir opinion also, Rakesh and mine,
I
and we'll consolidate what can be the good cutoff mark expected and what can be a good attempt. What is a reasonable score to get a better rank? That detail also we'll give you.
Correct. So guys, yeah, we are coming to that slide only. Okay, and then I have some more updates for you. I'm going to tell you that. चलिए, cutoffs की बात कर लेते हैं first of all. Okay, what can be the cutoff? So last year, if you see 2023, okay, the cutoff for general was 29.9. Okay, it's not that the paper was easy because it is 29.9. It is one of the very important factor is number of aspirants in EC shrinking. Okay, so we don't have the exact data. ISC has denied, even there was the PIL on it, but they have denied. Okay, so किसी ने file किया था, but they have denied. But they have told that the data will be released after the exam is conducted. Okay, but yeah, as per the trends, we are just expecting that the number of aspirants may be even little lesser. Okay.
Little lesser than last year, not too drastical, I guess.
Correct. So paper now, what is the inputs we have got till now is paper is moderate to tough and definitely better than the last year paper. MSQs भी ज़्यादा है and more MSQ always makes the paper challenging. Okay. अभी तक ये भी सुनने में आया है कि the most challenging parts are EDC and analog in this paper. Okay. And we have received very few questions. Maybe students ने attempt ही नहीं किया इसलिए वो questions नहीं लेके आए हमारे पास. We have received very few data from that. Okay. But rest the common subjects, the questions that I have received till now, signals was on an average level. Okay. One DFT question was good. Okay, other than that, control के जितना question आया moderate.
What about aptitude and maths?
Maths, I've got, I think, around 4 questions, regular questions. Aptitude also easy. Aptitude में कुछ difficult नहीं लगा. 5 questions, I think we have
Even
received.
students also commented the same that
Aptitude is easy. Maths also regular. I mean, maths, whatever topics EC is expecting, whether it is basis, whether it is complex functions, whether it is, the vector, everything is there. So it's a very regular maths. Okay, so the challenging part has been the technical. EMT के 2-3 question receive हुए, they were easy. Okay, on a good part, provided you know that formula S into Z, not minimum impedance. Otherwise, आप उसको भी lengthy करोगे. Okay, so it's a mix of easy and difficult, but yeah, EDC analog or number of MSQs are going to make it challenging. So Sanjay sir, over to you. आपने जितने questions देखे EDC analog के, what is your opinion on them?
And also about control signals.
सॉरी नेटवर्क, फर्स्ट ऑफ ऑल मैं नेटवर्क के बारे में बोलूं. नेटवर्क का तो इजी आया था, इजी टू मॉडरेट वी कैन से, आराम से इजीली सॉल्व किया जा सकता था, और वो उसमें बच्चों के भी कमेंट्स आए कि हमसे सॉल्व हो गया नेटवर्क. जहां तक सर ईडीसी के क्वेश्चन ज्यादा आए नहीं, मींस डेफिनेटली वो टफ रहे होंगे या बच्चों ने अटेम्प्ट नहीं किया इसलिए उसके डेटा वो प्रोवाइड नहीं कर पाए. और जहां एनालॉग है, एनालॉग में स्ट्रेट फॉरवर्ड क्वेश्चंस मिली. स्मॉल सिग्नल मॉडल्स बनाना है, क्वेश्चन को सॉल्व करना है, मतलब हम बोलेंगे मॉडरेट टू टफ. अगर आपने प्रैक्टिस की है तो क्वेश्चन को सॉल्व कर सकते हो. अगर आपने प्रैक्टिस नहीं किया और उस डायरेक्शन में सॉल्व नहीं किया है तो सॉल्व तो हो जाएगा, लेकिन इट विल टेक टाइम. तो इन्होंने एग्जाम में जरूर टाइम लगाया होगा उस क्वेश्चन को सॉल्व करने में. जैसा कि अभी एक स्टूडेंट ने कमेंट्स किया कि सर बाद में सब क्वेश्चन बन गया, फाइनल एक्सप्रेशन को सेट नहीं कर पाए, और वो एक्सप्रेशन एमसीक्यू में भी उसको गलत करके आ गए बिकॉज वो माइनस प्लस की गलती हो गई. तो उसमें काफी टाइम ले लिया, वो एक मिस्टेक के चांसेस है। तो एनालॉग मॉडरेट टू टफ है।
Yeah.
Yes.
EDC questions we have not received, but there are good number of questions, I guess, right, in the paper.
या
It
बहुत
seems to
क्वेश्चन
be
पकड़े
around
हैं,
10,
काफी
10 to
क्वेश्चन
12
सॉल्व
marks. 10 to 12 marks is from EDC. That was the report we got.
Yeah. And every time in the comment box, student commenting repeatedly the same thing. That is unlock tough fire. Don't worry, guys. So after the response key, we'll get the official paper and then we will discuss entire, not only EDC unlock, but entire paper we are going to discuss. Okay. So last year,
You guys comment on the comment section that what could be the cutoff according to you, because you have given the paper and you know the last year numbers also is seen here. You put the number in the chat box. How much could be the cutoff this year? By the time Rakesh will tell you.
Yes.
Come on, we want to hear you from guys, all of you. What could be the cutoff? What you are expecting? General. Okay.
Analog EDC tough, analog EDC tough, analog EDC tough. नहीं 22 तो नहीं होगा definitely
22
Thomas.
तो नहीं होगा
For general, of course, we'll talk about others also. इतना नीचे नहीं जाएगा. Sanjay sir, what is your opinion here?
सर थोड़ा बहुत प्लस मतलब -2 मार्क्स हो सकते हैं, -2
That's what even I'm expecting the same. See,
I agree with somewhere 26 to 27. That
Correct.
range I am expecting.
If-
I agree with Dev and others.
yeah, if I suppose, sir, if there are the same number of aspirants, the data we don't have right now, but if there is exactly almost the same number of aspirants as last year, then definitely it will be 26 or maybe 25 also, like 2022. But अगर हम ये मान लें कि aspirants थोड़ा सा decrease हुआ है, okay, then cut off correspondingly 26 से 27 या 28 हो सकता है. Okay, so I'll put it as a range. Okay, and 26 to 28. That's what I believe.
I too agree on this.
Yes.
Sanjay sir, what is your opinion? You agree with this or you want to decrease this?
3 मार्क्स कम होंगे और अगर नंबर ऑफ कैंडिडेट्स कम होते तो
Correct.
1 मार्क प्लस कर दीजिए
Correct,
सर, इसी के आसपास आएगा.
Okay, this
Yeah,
is what can be
somewhere
for
in there,
SCST, right? Okay, so that's what 26 to 28 because it depends on a very important factor, number of aspirants जो unknown है, but इस range में आ जाना चाहिए. That's what I believe.
But the last statement I want to give you and a suggestion to everyone that those who have done well by this time you must be knowing whether your exam is done well or not. Congratulations to all the students who have done well. For the students who have not done well, don't get disappointed. There are many other exams going to come. It's not a final exam. After this ESE is there, after that some other notification may come. We always say from BYJU'S exam prep side, we always say that your preparation should be like a journey until you crack some exam. Out of this journey, and on the way of your journey, GATE is one of the milestones. There are many other milestones going to be there.
One milestone is already ESE.
ESE is next visible already, and many more are going to come. Don't worry. And but only thing you should not stop is your preparation. Once you stop your preparation and want to start somewhere when there is a notification or when there is an exam, you are going to be in the same situation. You're not going to be improved. So your journey has to continue. Exams will keep coming in on the way. So this is one of them.
So guys, to assist you in the ESE paper one also, now GATE is done. Okay, so tomorrow, that is just Monday, 12th of February, there is going to be a session on ICT. Okay, Information and Communication Technology. Okay, and that's going to be at 6 p.m. Okay. Then you have 13th Feb and 14th Feb. I'll bring you the maths and aptitude revision through some important questions. That will be at 11 a.m. Okay. 15th Feb, Sanjay Rathi sir is going to bring you a session on material science. That's again at 11 a.m. Right. And 16th Feb, advanced communication at 6 p.m. Okay. So some important subjects. This belongs to paper 2 basically, advanced communication. Okay. But rest is according to the paper number 1. Okay. So we are assisting you the complete week, all 5 days, for some ESE preparation also. Okay, and now one more thing to add on, like sir was mentioning, there are several other opportunities, and one of the big opportunity after ESE also is going to be BARC examination. Okay, oh guys, this is a correction. This is definitely not 12th. I'll ask him to correct it. Okay, it's definitely not 12th. Okay, so this I think will be
the session maybe.
Yeah, date. No, session date.
YouTube session maybe.
Yeah, YouTube session. 15th or 16th Feb. The BARC 2024 1-month preparation strategy. The BARC 2024 1 month, because now the BARC examination is on mid of March. I think 16-17 March BARC exam is there. So almost 1 month is left. So what's going to be your plan for the 1 month for the BARC? Okay, then how to utilize the next 6 days for the ESE? Okay, efficiently. That's going to be taken by Sanjay Rathi, sir. Okay, then there will be a session. If the GATE 2024 has gone bad, what are the bigger opportunities than GATE? Yes. Okay.
That is what the question asked by someone actually. What after other career opportunities?
That's what.
Correct.
And some bigger opportunities than GATE. Okay. through the gate preparation only. Separate prepare nahi karna hai. Through the gate preparation only, you can take the benefits of some more big opportunities. Then we'll have a session on last minute tips for the engineering services prelims and the roadmap after gate. So several post gate sessions are going to come up for you guys. Okay, stay tuned to the BYJU'S Exam Prep YouTube channel. Okay, and enjoy all these sessions effectively. And also, guys, now, okay, if you feel that you're looking for the preparation of GATE 2025 or 26, maybe this GATE attempt was your trial. Yeah, maybe your juniors or your younger brother, sister looking for some GATE preparation. So the complete full-fledged BYJU'S exam prep courses, okay, are available on the app as well as the web. Okay, we have the complete courses for 2025 as well as 2026 available. Very important thing in both the formats, English as well as Hindi. You can choose the level, or you can choose the language of your area, जो आपको ज़्यादा comfortable लगे समझने में, and you will get the access to live classes, facility of recorded lectures, study material, mock test, practice quizzes. In and all, everything to make you exam ready is there. Once you enroll, you don't have to see anything. Everything, study material, test series, all of these things are available here by your favorite faculty. Okay, now for any more details about the course, there is a number mentioned, and one more thing I'll mention here. Yes, so if you need any more details about the courses, yeah, if you have slight confusions, whether GATE is beneficial for you or not, any preparation guidance you're looking, okay, or anything regarding to our course, you can directly book your free one-to-one guidance session, okay, by contacting this number 924-133-666. Okay, or else, or simple solution batata hu, you can go to the description of this YouTube video, okay, and there is a counseling form. Okay, very basic counseling form. It will take maybe 20 seconds to fill that counseling form. If you fill that counseling form, automatically our team will book your counseling session and they will guide you regarding to the GATE preparation and also regarding to the courses. Okay, so that you can make a decision wisely there.
Your needs and requirements may be different. Every student will have different requirements. Accordingly, you will be guided where and how you have to prepare for it.
Because there are different modules available in different languages, so you can, take all those benefits. Right. So guys, now see you on 18 February. And for EE students, we are coming live in another next 1.5 hours, 5:30 p.m. We are coming live to have that discussion.
Electrical students, all the best.
All the very
Yeah,
best. This is done. Yeah. Okay. Bye-bye. Thank you. Stay safe and take care. See you live once again after the response key is released for electronics.